Okay.
So
Who is scribing? Do we have a scribe?
should we go over? Yeah. Should we continue? Yeah.
Yeah. Just
Okay. So in that case, the user content should be protected from the iframe, but it does not need to be protected from the top level frame, which is the Doctor website, because the user trusts the Doctor website, but the user might not trust underneath it. And that's where, if getUserMedia is called from the WebRTC provider iframe, maybe the streams should be isolated or protected, for instance. And in which case, there might be a need for the Doctor website to actually express that, hey, if getUserMedia is actually called from the iframe, then it's fine. But I also want that these streams be isolated. So that's the first thing that we might be able to do there. The second thing at the network level is that the WebRTC provider iframe cannot get access to the keys, obviously. On the other side, the Doctor website maybe can have access to the keys. But still, it's the WebRTC provider that will need to send to the other party some key identifiers so that on the other side, they will be able to retrieve the keys. So there's this notion of key identifiers, which might be useful in some ways.
So maybe I'm like misunderstanding, but as I understood it in the current design, the web application never gets to see the keys even without isolated streams, right? Because the keys are just stuffed in the browser and never exfiltrated.
Yeah.
Am I wrong?
I believe that's how PERC is supposed to work.
No, but I mean, even without PERC, I mean, just ordinary WebRTC, even if you don't have isolated streams, right? The
never gets the DTLS keys, right?
I mean, you can. You get to see the DTLS fingerprints and presumably modify them, but you never get to see the traffic keys if you're a web browser.
So
they're hop-by-hop keys
yeah, there we are talking about the end-to-end keys. So you had another encryption layer just for the content, so for the payloads that would go, and you would encrypt it at the initial node and decrypt it at the final node, but not at any intermediary node.
Yeah, this is PERC double, Ecker, what we're talking
Something
about.
like that.
The payload key.
Just to clarify, we're not talking about the current situation, we're talking about the future.
So this is supposed to be,
yeah.
Okay, but so I'm supposed to understand this as PERC?
PERC, and sort of in that context. We're not sure exactly whether the whole point is, what is the use model? Does it correspond to PERC? Is it something else?
Yeah,
okay.
we're just trying to have like
but think of it as the PERC payload keys that we're talking about here.
Okay.
Yeah.
Whether it's PERC or not remains to be determined based on what we're talking about.
We are trying to see the trust models and what needs to be, what are the requirements to actually make these trust models. So, okay, that's pretty clear. So now if the web app is fully untrusted, it's the full general solution. So the audio, video, and content should be isolated. So you do a getUserMedia call, it should be isolated from the start, which means that currently you might need some UI for the user to express, oh, this is this website. Maybe the website can express that it wants isolated streams, but you need to present that information to the user. So it's a difficult topic. We do not have anything there, but maybe you can envision things. I also want to mention that if the streams are isolated, then nothing yet anymore. But maybe it's fine. Of course, web apps cannot get access to the keys. Again, key identifiers may be fine. But then you need a way to hook this untrusted web app with some ID providers, or have something like an EME model, so that you can go from key identifiers to key values. But this mapping should be out of the web app control. So it should be the browsers that implements it. So there would be a need to do things there.
So Ecker, I think this is trying to correspond to the PERC model.
And in that particular case, as well as in the other case, the web app cannot do its own encryption because the web app cannot get access to the content and cannot get access to the keys. So these are the three models we've identified so far. And as a conclusion, if we look at the WEBRTC API level that we're defining, the changes are pretty narrow. And it seems that it's not the most difficult part. We might be able to cover some cases with partial trust. And maybe there's some use cases that will be interesting enough to trigger interest in terms of implementation and deployment. If there's no trust at all, I think we need something like IDP and piggyback on it. So probably we would need to work on IDP, ship it, and then improve on it to actually add end-to-end encryption. And yeah, also delegating crypto to the web app is not always possible depending on the trust model. It's only in one trust model where the web app is fully trusted that we could envision that scenario. So that's it for what we had as information. So now I guess we can maybe have discussions on this.
So what do you think, Ecker? Does this make any sense to you? Does this make any sense to you, Ecker?
I'm still trying to put it through my head, to be honest. I mean, when we did PERC, there was like basically the assumption that PERC had to be wired into the browser because it was we couldn't figure out how to like not wire into the browser. And it seems like
The untrusted case, right? That's why it was wired into the browser.
yeah, right.
First case, it doesn't have to be wired into the browser.
So there's nothing inherently that we have to do with the first slide here, is there? This is just it. It's the partially trusted case that we might want to do something about. I don't think it's all that interesting, but you know.
Very hard to reason about is my concern.
I don't know if anyone can like make this a little bit more concrete for me. Is there a like kind of use case somebody could sketch? Because I'm struggling to see.
It was the Symphony case that was actually described. That's a real app.
Yeah, maybe I didn't understand it well enough.
The use case
still
is that,
struggling to see
especially in banks and financial institutions, they have a very strict security model. So they want everything in-house, everything deployed in their premises. So it is very difficult to provide any kind of services to banks and financial institutions because they deploy
compliance.
So sorry,
to provide compliance, you mean?
Yeah.
No,
So in the
even-
Symphony case, the bank is serving the JavaScript, so it trusts the JavaScript, but the provider is Symphony,
yeah. For example,
which
you
is
can
somebody they don't trust, so that the JavaScript is trusted, but the service provider isn't.
I think it goes even a little bit further in the sense that like basically the keys come from the trusted web app, right? And they have the ability to revoke these keys at any given time.
Right.
Stuff like that.
But it is not. Let's go a bit back because it is not about the keys. It's about that when you get if you are using an SVU environment, the SVU has access to the unencrypted media. So to be able to rely from one participant to another, it has to decrypt it, and for some moment in time, it relies on encrypted in the SVU. So even if you trust the SVU code, if you deploy in a cloud provider, you may not trust the cloud provider. It may be collocated with another virtual machines that may have access to the memory of the so deploying everything outside of the bank is not allowed. So even if you have implemented your own SVU, if you deploy it in a cloud environment, it is considered not secure in this kind of highly secure scenario because.
Well, I mean that one I think is like a little bit. I don't get it then because like so if we talk about an end-to-end encrypted scenario, and you do deploy in the cloud, theoretically, if you do it right, that SFU doesn't get access to any of the media. It will be able to do any kind of denial of service, like drop packets and stuff like that, right?
But
there's nothing we can do from the WebRTC perspective to prevent that.
No, but you're prevented to have access to the content of the content. I mean, providing denial of service, I think that it is far of the scope of WebRTC. I mean, you cannot do anything to prevent denial of services of misbehaving. I mean, what we want is to ensure that the privacy of the content that it is being transferred is not compromised. That the SVU cannot be hijacked and the content be either changed or even recorded. So that's the problem. I mean,
but for that you only need like 2 layers of encryption, like basically PERC double, right? And like
I mean, and
that's the scenario.
These different scenarios are about like where the keys are coming from and who can have control over the keys for the end-to-end.
Yeah, but Tim was asking about why this double was needed. It's not. So it was one step before that. So why we need the double encryption?
So the original question by Tim was, I don't understand the use case. So does that answer your question, Tim? Do you understand the use case?
Yeah, I'm trying to understand where the keys go. Like,
well, that's a different question, right? Let's go one question at a time.
To be able to access them.
Well, are we clear on the use case? And
Yeah,
then we
but I
can
don't
go
think
into
I
the
believe
key
it,
question.
because
But
banks
that's
need to access the media, because that's a compliance requirement. So I don't understand the use case.
It's only when you
I don't
transfer.
believe it. I understand it. I don't believe it.
This isn't just for banks, though. I mean,
Okay.
if you're running something like Hangouts, it's nice to not have to be able to have the media on the server at any point in time, because it's a liability.
Yeah, no,
So-
but that use case I understand, but the banking one I just don't.
Well, it's
Well, it
very
doesn't make sense.
it's very
Wait,
similar.
What
They have-
don't you understand? The banks can access the media, and this is partially trusted use case, right?
That's not double layer.
Yes, it is. Yeah, it is.
So you can, Tim, you can, I mean, you have multiple options there. In that case, for example, you can still do recording by, for example, injecting like another user into the conference, which is trusted by the bank and is doing the recording and stuff like that, right?
Well, that's still possible. It's the fully untrusted case where the media is you now can do the recording.
Yes. Except if you record it at the endpoint.
Well, normally you would not be able to do that because the streams would be isolated. So
The streams would be isolated.
The browser
So I guess
will
you're saying it
protect
wouldn't.
from recording at any endpoint as well.
Yes, if the browsers are all endpoints, yes. Sorry, if all the endpoints are browsers.
Yeah.
So can we go to the slide where they have the 3 untrusted, fully trusted? So I just want to say that the third one, where the web app is trusted, I think is a use case worth providing the web app the tools to implement that, even if we can't figure out the other 2.
But okay, I guess I'm still trying to figure. I guess I'm still having trouble following. The case of the web has trusted you want to exfiltrate the keys. I just don't understand what the.
This the third case. This the third case, Ecker, that you're asking about?
Yeah.
Just a limited. Okay.
I just want to be able to run the same thing as Hangouts, but not have the media unencrypted at any point through the SFU.
I mean, right.
This is the Symphony. This is the Symphony case, right?
It's very similar.
Yeah.
Right. But I want to be able to do that as a web developer.
Yeah. So this is Ecker. This is the scenario where the bank is serving the JavaScript, and they're using someone like Symphony as their provider. They don't want to trust them, so they're able to serve their own keys. They just don't want those keys to be accessible to Symphony, which is running the MMD or whatever you call it, the centralized conferencing server.
I mean, I guess I don't understand. This seems to be the use case, precisely the use case that PERC is intended for. So,
No. Yes and no. Yes and no. For the double encryption, you are right. No, in that case, all the mechanism about securely providing the key around to all the conference or the other documents in PERC are not useful, since you trust the web app So you can have a simple JavaScript API to pass the key in, which is not something that Perk was made to allow in the first place, unless I'm mistaken.
Like I said, there are different documents in Perk, but the one specifying how the packet should look with 2 layers of encryption is the only one really relevant here.
Well, that one, the document which defines double basically only defines how to do double encryption, which applies to all 3 of these use cases. And
I'm saying the third use case only needs that document. We can ignore. We're not talking about the other pieces of Perk. Just that one.
Well, I mean, so okay, so I mean the intent of Perk is to. I mean, so going back to the basic design principle of how this entire thing was designed was to avoid exposing the key material of the web application, and like. So, and the purpose of Perk is to allow you to provide an SFU while still not within the key material of the web application, and like, so since the basic design principle is not to expose the key material of the web application, that seems like unattractive.
Well, so Echo, that scenario might be, say you're using Hangouts or some service, you don't trust that service, you want to completely own the keys as the enterprise provider. Right, in which case you don't want the JavaScript to get access to the keys because it's part of the service. You don't trust the SFU, you don't trust the JavaScript, right? So that's, I think, the Perk scenario is the general case web app is untrusted.
Yes.
And that's double plus the key management, I think.
Yes.
Right?
Yes.
Yeah.
Plus isolated streams and a lot of things.
I guess that also is, UN said that implies things like isolated streams and stuff like that.
Sure, isn't that problem solved?
But I get. Yeah, I guess, but my point is even ignoring the even ignoring the case of of isolated streams, like a basic design principle was never to expose the traffic keys to the web application, and that's like why we did not doing ISDES, right? And so so I guess I'm trying to understand like what the I'm not super excited about designs that like compromise that invariant.
There are two keys though. One is exposed to hop by hop nodes, and one is exposed to the first and the last node.
Okay, but I mean, right? I know I get that, but I mean, how do you intend to synchronize the keys for the conference?
It's up to the first and the last node to exchange them securely.
But I mean, you're assuming you only have a 2-party conference.
No, I assume it's more potentially.
Right, but then you need a Perk machine in order to synchronize the keys.
Well, it can be 2 or 3 if you. I don't think it's a problem there.
I will use a single key.
But we can stay with the scenario with two people if that's helping to simplify the discussion.
But that's up to the web app.
I don't. I guess okay. Let's take it. Maybe I'm just like really. I think I'm really missing something because like the chain of logic where you get double encryption is you say, well, what I really want is like everybody in the conference uses the same key, but TTLS doesn't provide that. TTLS provides like
sure.
TTLS provides like separate keys for each pairwise connection, and so we need to synchronize those keys. That's how you get into Perk in the first place. So I just don't understand if you don't want.
I think our time is basically up, but let me make a proposal for next steps. I think we've at least gotten to the point where we understand what we're arguing about, which we didn't understand before. And we have these 3 cases which we could conceivably write up and then post to the working group for further discussion. So I think we've made a significant step forward in that we now have enough to even have a discussion, which we didn't have before.
And Bernard, if I may briefly interject there, like even if we assume the general case is solved by Perk, the JavaScript APIs needed for Perk have not been solved. So
right. So yeah. So we're trying to get to the point where we understand even what the problem is. I don't think we necessarily know that we have a JavaScript API for any of these things, but we're just trying to first understand the use case and what the requirement is.
We know we don't have it yet.
We know we don't. Right. So does that make sense as next steps, which is to try to write up? Well, we're certainly going to post the slides because that's what we do. But to write this up in enough of a form that and post it to the list so we can have
Yeah.
more discussion?
That'd be great.
Okay.
Okay.
So thank you.
Who's taking on the problem?
Who's yes?
Yeah, I
I know
do
who
it.
I want to
I
nominate.
can do it.
Yes, thank you,
Can-
UN.
Would it make sense to put this on the list of if we have time at the end?
Well, I'm not sure how much more progress we can make, and by the end, Ecker will be asleep. I think he hopes.
Really hoping so.
Okay.
I suggest somebody does a diagram.
Well, I'm sure we'll have lots of diagrams and
Okay. Yeah. Sure.
explanations and all kinds of stuff in the write-up.
Gwen is in charge of diagrams.
In charge of the diagrams, right?
Okay.
Thank you very much. This is very helpful. Okay, so let me just paste the slides in so everyone has access to it. Okay, Peter.
First question, do apps want to send audio, video, or data? Answer is yes. They want to send all of them. Next question, do they want to send them over RTP, SCTP, or QUIC? Answer is also yes. Currently, we don't allow all those combinations. You want to send audio and video, apart from what we talked about, where you can capture from web audio and send over a data channel. The nice path that we support, you can only send audio and video over RTP and data over SCTP, and potentially data over QUIC if you take the QUIC extension spec or the version of it in ORTC. But it would be nice if we could have audio and video and data all over the same transport. So we've talked before about having a flow of media from left to right here, but having a data channel also be plugged into the same transport, so it can be in the same congestion control context and can be terminated at a server or device endpoint using one protocol instead of several. This has come up in a number of the use cases that we talked about yesterday. So it's kind of a repetition there. The game one, the VR one, the conference sharing thing, remote control. So it'd be nice if we could fill in all the boxes. And there are ways we could do it. So for example, if we split out the encoder from the RTP sender, we could have media go over SCTP. If we made a lower level RTP transport, we could have data go over RTP. And if we added the QUIC transport along with the encoder being split out, you could send media over QUIC. And then the application could choose which protocol it wanted to use for which type of content for its use case. So maybe there's a server or an endpoint that wants to use QUIC. Maybe someone wants to experiment with different techniques in SCTP and put media over that. Maybe there's a server or an endpoint that wants to synchronize some data with audio and video, but really wants to stick with RTP. So I have some more slides that cover pieces of transports that are in ORTC to kind of understand what they are, and potentially other transports we could have, like RTP transport, a low-level one, that don't exist anywhere. But kind of like to pause right here and get a sense of the room of how much interest there is in filling in all these boxes. I'm personally very interested in filling in the QUIC boxes, and I also think there are a number of use cases for the RTP box. And I think it's relatively easy to support those, with the exception of the encoders being split out of the RTP sender, which is something that we've talked about a little bit yesterday. But there might be some options that we have in relation to worklets that I'll bring up. So a sense of the room.
Shachar from Peer 5 here. So I'm very up for adding QUIC to data channels. A question about it is whether it's a closed box which will predefine the congestion control, or whether congestion control, different congestion algorithms can be decided from the app.
So I don't think it'll ever be the case that the app can implement the congestion control, but Quick does allow for pluggable congestion control. So you can definitely imagine an enum where you could pick between a certain set. Right now, the Quick implementation in Chrome supports Cubic and BBR, but we've been looking into adding the WebRTC congestion controller into there also.
Just a question for Peter. When you choose congestion control, you can't choose it on a per stream basis, right?
No.
You have to choose it on a quick transport basis when you create. Right. So it would have to be in the constructor.
Yeah, or a setter. Yeah.
So I heard use cases for RTP and Quick, and there's SCTP in the middle. Do we have use case for that one, or is it there for completion of?
Well, I mean,
study.
That's a question for the room. Is there somebody that would like to send media over SCTP?
So taking a step back here, like let's take SCP off the table for a second. Maybe useful to use in sequence. Like the RTP one is crazy. Like, you know, Norma's not trouble design actual transport, and RTP is not a transport. It's just like packets. I mean, like.
Oh no, but
it's actually in widespread use.
No, I disagree. I'll show you in a second that what you need is you need encryption and congestion control, and RTP provides both of those.
Yeah, there's a lot of VR scenarios that people are doing nutty things like modifying codecs when all they want is synchronized data.
Yeah. Like,
don't do that then.
Yeah.
Why not?
That's not actually data, it's something else.
Yeah, it is actually data.
If you say so, but I mean.
Is a real-time event streams? I mean, RTP is good for that sort of thing.
It's basically the data is going through an SFU. So they're just sending the data with the audio and video, and they want it to be propagated by the SFU to the endpoints as it is, you know, with the audio and video.
Is it timely?
And they should define codecs for that. Not treat it as a generic data.
That's the whole point. Is the web? They can't define a codec in the browser for every kind of different thing they want to do. That's what they're doing now, and that's what doesn't work.
So wait, SFU.
SFU forwards it to everyone indiscriminately, or does it select on
It like
volume,
it
or
forwards the audio
how
and
does
video.
this
It's
work?
like a game with your location. You send your location along with your audio and video, and it forwards it to all the other participants in the game, like it would the audio and video.
Right.
Yeah, and how is that synchronized? Like that requires like a whole new set of APIs, like synchronize that shit in the browser. That's not just. It's not a matter of the other side.
It's basically just a data channel like message thing.
Right.
That's all they're using now.
How does it get resynchronized on the receiving side?
If
doesn't have to be
unordered
precisely
worked in,
synchronized.
so if unordered works in the data channel, you'd get almost exactly that already. Like that's almost already done. So I don't get it.
No, they're using an SFU to distribute the data, so it has nothing to do with the existing data.
So what you're saying is this is back to it's too hard to do the data channel on SFUs, despite the fact that Jitsi
the
already
SFU
does.
distributes data to a group, and that's what they're doing.
All the SFUs already do data channel, like Jitsi does.
They don't do it for this. That's in fact I've gone through this with people. They can't use existing SFUs.
I promise
exactly
you,
because it doesn't have this functionality. They're writing it. They're writing this RTP data.
I promise you, in an afternoon, you can have it working in Janus. Like really, it's not. This isn't rocket science. Like all of the plugs are there.
Look, I've gone through this with 10 different game developers. None of them want what you're selling. They're all using this, and this has already been implemented by at least 4 different implementations, and it's shipping in the field. So you're arguing with people who've already made a decision, already using this.
So just to clarify a little bit, I think Eker is right in saying that in a browser on the rendering side, there might be an issue, but maybe the games you're talking about are native games using WebRTC and not actually, so that the rendering in that case is handled natively, and in that case you can do synchronization between this data and audio and video.
But then they don't need a WebRTC API.
They're using exactly the same native API that you'd have in WebRTC.
I understand, but it doesn't need to be defined as a web API with WC because they like native things. I mean, like they add new APIs. This is about designing things for this project is about designing things for web browsers.
So
he's saying that there are clients that are entering into a game conference, if you will, that are mobile apps that are using this, but it's not. They're not able to do it with the web app. They want the web app to join.
So we
want to be able to do the same thing in the web app that they can do in the mobile app.
Yeah, they're basically using the data channel interface that exists today, just sending messages over the RTP transport.
Right.
Let's take a real big step back and ask the question, do we want to be standardizing 1, 2, 3, 4, 9 different things, or are we happy with fewer? Can we accept the fact that it would be possible to do certain things and that possible is sufficient?
So we don't have to standardize 9 different things. If we standardize 3, we'd be done.
No, like you want to stuff this data over RTP. The next thing you're going to do is you're going to have to standardize some actual the actual code points in IETF. It's not
No, we don't. It's RFC 4103. It's already defined. That's what everyone's using. It's already an existing RFC 4103. We're done. So no standardization work needed.
And we don't because the only thing you're sending is T140 text.
And we don't
need that can be done in a JavaScript library, but it's the format in RFC 4103.
Right. We don't need to specify you don't need to specify what the payload is in the IETF. We can just let the web app decide what the payload is. That's the whole point of
that's like no different from tunneling. That's no different from tunneling.
So
this is like UT1. Like I'm looking at this document. This isn't like freeform ASCII bit. This isn't like freeform 8-bit crap. It's like text.
Ecker, that's not what we're talking about.
So
you just quoted 4103. It's like not like freeform bits.
No, but he's not saying that anybody has to. We don't have to put that in the browser. We can just allow the web app to send whatever RTP packet it wants, and it chooses the payload.
But what will the payload type be?
Whatever it wants.
But
it can make up its own.
It's dynamically allocated.
Yeah. Yeah. What will appear in the SDP?
Whatever it wants. We're not talking about SDP.
Yeah.
Huh? Nothing in NV is SDP.
So can we step back a little bit and see if I can summarize the motivation here? The motivation here is that it's proven difficult to get people to adopt the SCTP data channel. It's not that we believe that the SCTP data channel genuinely can't do any of this, except maybe synchronization. It's that we've found it difficult to get people to adopt it.
Well, no,
it's more fundamental than that.
There are 2 things. One is that we want audio and video and data in the same congestion control context.
But that's also possible. Like we've just decided not to do it.
I don't think that what you are going to do is provide data over RTP. I think that what you are going to do is to provide an interface that allows to send from the raw RTP, and the applications can hack that API to send random data as if it was audio and video, but you don't want to send data over RTP. You want to, I would say that it is a side issue or a hack of an API that it is proposed. I mean, I think that the rationale is not to provide data over RTP, is that as a side issue of an API that it is being proposed to send raw RTP, the web apps may use it and hack it to pretend to send some data as it was audio or video.
So if we can look at pros and cons of this approach, to me it seems like the biggest cons is that in terms of web browser, there's no processing model for this synchronized data yet. So if it were available, I guess it might be a no-brainer, but it's a con, I think. There might be some pros. For instance, if we go to NV and we remove SCTP dependency altogether for WebRTC NV, that might be easier for some people. There's the congestion control that might be another pro. So is there additional advantages of this approach that you might think of?
I think the ease of termination with existing RTP endpoints, like the ones Bernard was talking about, and the shared congestion control are the main ones.
Yeah, and I just wanted to double back, Varun. The main reason why we're not able to do what Tim's asking for is that the timestamps that go into the RTP packets are not the same that go into the data channel. So the receiving side has no metadata to synchronize these two forms. You could indeed do some more work there to put the 64-bit RTP header extensions that would allow for the synchronization.
So that's actually a really interesting idea. So you have an extra method which just says this data channel is timestamped, and every packet that goes out over that unordered
thing
channel
that
is
people didn't
timestamped.
want to do, which is do media over SFTP, right? That's what you're asking for. That's a lot bigger task.
No, if you're just putting a time, if you're just defining that there's a time.
Remember, this is going through an SFU, so it expects the RTP kind of payload format.
Okay, but that wasn't what we were talking about there, though. We're talking about if you have a data channel that has a TP timestamp when it gets sent, okay, and then the SFU just simply distributes it. It doesn't care what the data is. It just simply sends it to everyone. And when the receiver gets it, it can just it could compare that.
But I think that there are two different things. I mean, because we have already a use case that we want to allow to send metadata synchronized with the audio and video. That is one thing. And I think that the main reason for maybe why people are using the sending data over RTP is because RTP and SCDP has different queues and different latencies. I mean, as they have different congestion controls, there might be a big desynchronization between the data that you send over data channels and over the data that you send over RTP. So this is one of the main reasons.
So the congestion controls issue is something that we've talked about since the very beginning. They can run in the same congestion control scheme. We've already talked about a number of possibilities for this. We just haven't done any of them. The current congestion control scheme where they fight against each other was we've always known is non-optimal for some cases, but it was simply the easiest one to do.
So just going back to what Randall said about synchronizing RTP, it's not that simple because each SSRC has its own RTP timestamps in their own RTP timestamp space. How you synchronize them is usually through an RTP sender report, which says the RTP of these streams corresponds to this clock over sender reports. This is not possible today if you do it over SCTP. You would have to either copy those mechanisms into SCTP or provide a similar mechanism into from SCTP to RTP with which would be metadata, which Sergio was talking about,
so
that tag all things with a consistent timestamp from the application.
It's very trivial since we control the data channel format to have this be part of the data channel format that is used over SCTP. Basically, if you create a data channel that's a timestamp data channel, you would simply have each data message have a timestamp at the front, and then at the receiving side, it would do whatever appropriate calculations are necessary to tell you what media time for the receiving media that it's equivalent to. Because on the receiving side, you're not receiving it as RTP either. I mean RTP timestamps either. You're not getting.
But still on the receipt.
No, you wouldn't provide the timestamp raw. You would in the on message callback, it would provide you the relative time to the media streams to the media streams you've decided to synchronize it to. Because even with RTP, you have to decide which streams you're synchronizing it to. So it would be when it delivers the data message was sent equivalent to this timestamp. Two are separate the data.
For defining audio and video over SCTP? Is that what I'm hearing, or just?
No, I think what we have heard is that there is a need for synchronizing your data with the audio and video. Right?
Yeah,
But
so
that's independent of which protocol we choose, basically.
So at this point, it seems like
synchronization. It's
or at least knowing.
control.
To be precise, we have identified some cases in which some data needs to be correlated with some timestamps.
Yeah. Okay, but to up level again, would it make sense to make the RTP transport a separate topic in the open slot later? Because I actually wanted to cover other stuff.
We still need to get to the episode, so we can put down a separate discussion.
Okay, I didn't expect this one to be quite so exciting. The one I was that I'm more interested in talking about is the quick part, but there's a whole time slot for that later.
Again, until we solve the issue of synchronized rendering pipeline and synchronized sending pipeline, sending timestamp is not really useful. You have an event, you send the event, you schedule the event at some point, which will be maybe the point you decode the same frame with the same timestamp. And then at some point, the JavaScript will actually execute the callback. It's not guaranteed when it will happen. There's no guarantee there. So for pure web browsers, the timestamps are not useful, which does not mean that some WebRTC endpoints, which are native applications, might take benefit of that. But
right, that's what I was going to say. Is there are going to be endpoints that aren't web browser endpoints.
But back to your original question.
Right. So we have interest in the bottom left box, and we can talk about that more later. Doesn't sound like there's too much in the middle top box, and so far someone at Peer 5 expressed interest in the bottom right box.
My next question was encoders and quick transport. Do you want to send encoded frames with some metadata onto the quick transport?
Yes.
And whatever that metadata might be.
We talked about what metadata that might be yesterday.
And I thought that was going to be RTP transport.
I mean, we already have audio and video over RTP.
I was thinking RTP over quick.
You could do that. So the way that I've outlined it here is that the application can choose how to map the encoded frames onto the quick transport. So if you want to do RTP over quick transport, you could. I personally wouldn't do it that way, but
I thought the RTP over quick was only making sense as a adapter kind of thing for existing solution.
Sorry, adapter?
Yeah, like existing solution that would create RTP would then be able to go over quick. But other than that, there was not a real use case they were pushing for that. That was my understanding. Did I miss something? So globally, there is not a real super big use case for that moving forward.
I think there's definitely
expression. I think he agrees with me.
I think there are definitely use cases for audio and video going over quick that doesn't involve RTP.
The question is how much of the global pipeline that already exists you want to throw away?
Well, I mean, there are lots of pieces in the pipeline. We're just talking about the transport piece here being different between RTP and quick. There's a lot of code that isn't the transport.
I mean, it depends what you think the transport is. If you think the transport is UDP, that's one thing. If the transport is RTP.
No, in this context,
it's quite different.
It's this is what I was going to go. It's mainly the crypto congestion control and partial or optional reliability. So those are the things that are provided by all these things that we call transports.
Yeah. So also to be clear, for the top left box, top right box, the quick audio video quick, you also have the option of going to the ITF, defining what audio video is over quick if you don't like RTP, right? But I guess what you're saying is something different, which is you don't want to have a standard, but allow people to define how they transport it themselves.
Yeah,
I'm just saying that there is an alternative there. You know, you could have a quick sender or a quick receiver if you wanted to.
So we have a separate time slot for how that how it can work and the specifics of how
Yeah,
the
so
quick
that's
API
what
would
I'm
be?
curious about, because at the end you need some metadata. Some of that is going to be timestamps. Some of it is going to be sequence numbers. These might be frame numbers, or so there's details in RTP which you would have to follow or recreate. I'm open to like killing RTP and copying some of the best practices from there.
And we have a time slot for that. We'll definitely talk about that.
So we have 2 minutes left, and I'm just trying to understand if we have any conclusion from this. We're going to have another session on RTP transport. Do we have this? I think we concluded we still want to do audio and video over RTP.
I hope so. Spent a lot of time on it.
So that we have a conclusion. Do we have any other box that we have consensus?
Well, I'm assuming we also want to continue to do data over SCTP, at least for the short term.
Okay, so we got three elements.
And I guess I would claim we have consensus for the boxes that say done and not much else.
It seems that SCTP audio video, there's no interest.
Okay, SCTP, whoever's scribing, we don't want SCTP audio video. Is that correct?
But to be clear, you can already do it. It's just that you can't. There's no encoder.
There's no encoder.
Right. Other than doing it in JavaScript.
Are there any other boxes that? How about the quick transport, the lower right box?
Sometime in the future, not today.
Why not?
Because the world of quick is unbaked.
It's baked enough.
Really not.
Yeah, really not.
So, people are already using it. Like, what do you mean it's not baked enough?
The fact that people are using things in their own environment, Peter, does not mean it's sufficiently baked to be done. As I think that the fact
it's sufficiently baked to start an experimental implementation in a browser and put it behind a flag for people to try.
Yes, for question at hand is standardization.
Yeah, well, standardization takes a long time, so we can get started now.
Yeah, I'd really like to finish 1.0 of both Quick and like WebRTC before we start adding.
The whole point of this face-to-face is to kick off NV, right? It's what we want to have in the next however long it takes.
I do appreciate your perspective, Peter, but it's not mine.
Okay.
I would like to just second adding Quick again to data channels, because I think it's an important use case, especially in our use case of doing like a peer assisted video delivery. Anything.
State your name.
Shahal from Peer 5. Sorry. So I think in our realm of like this very difficult optimization problem, where we need to have a modern congestion control and a few more use cases. So I think improving transport to Quick would be very beneficial. And we can obviously test it and put it behind a flag.
And I think I would also second the quick transport and something above that would allow media to go with it.
So I hope we all agree that RTP over Quick is currently not even baked, not even half baked, not even quarter baked.
Is there even a baker who wants to bake it?
Like, we're not talking about RTP over Quick. We're talking about media over Quick.
Yeah.
Right.
It does not have RTP.
Speaking of, well, that basically says to me that you don't even have all the benefit of the experience of RTP, but you'd like to put it over Quick. So we can do media recorder, right? And that works, but that's not real time.
Sure it is.
Okay.
You can do real time media over Quick.
Yes, and it's also possible, and that would be a great return to the world in which we have absolutely no standards and it's free for all. Just like the early days of the internet before we actually had any of these standards for doing voice calling.
Bernard was bringing this up earlier, and we have a time slot for that. This time slot was more about looking at the big picture of all the transports.
That was a big picture comment, so take it as one.
Okay.
I have a big picture question because I don't know these pieces well enough. Let's pretend we have RTP transport, SCTP transport, quick transport, and I'm writing an application. Why would I want to use RTP or SCTP or quick? Like, what's the pros and cons with these ones?
It depends on what your use case is. So if you're doing one of these games that's heavily built around RTP, but you want to add data,
you'd probably want the RTP transport doing data. If you're interested in doing everything over QUIC, because like Pure 5, you want to use QUIC, then you would use QUIC for everything. If you just want a data channel and you're not particular about which one it is, you probably just get the default, which will probably always be, well, for Pure Connection, always be SCTP. For NV, like which one do you say new?
That sounds more like a historical
Yeah, what I'm seeing from developers is that developers who want to transfer files want QUIC. They're not real happy with SCTP as it exists right now, and they like QUIC a lot.
And what about media? Because right now we're using RTP for media because that's what exists.
I haven't personally heard from the games developer side any interest in doing anything other than RTP. My understanding is the interest in QUIC media is more from like this broadcasting, like sports kind of case, low latency broadcasting scenario. But that's not what I see from the games developers. And the games developers, like Peter said, who want the doing audio video, want the data kind of distributed by the SFU. They're the ones who want the RTP transport. There's a lot of games developers today using SCTP, mostly in the unreliable mode for kind of small messages. So we see a lot of that today. They're having issues. They're fine with the peer-to-peer, but when they start doing stuff on the server, they're not very happy because they don't like user SCTP live for that kind of a scenario.
So the other thing is,
so here's a question. You're saying that the main thing you're hearing where people
fix some of the bugs and get the larger chunk size or whatever, they're still seeing interference with the audio video. The SCTP can.
So they're either doing file transfer and media at the same time, right?
Yeah.
So there's the coordinate the congestion controls, which has always been an issue that we just simply not an API issue. It's just an implementation issue.
Am I right in thinking both of those would also, those tunings and optimizations would need to happen with QUIC anyway? So it's not like, it's not new work. It's not like
QUIC has adaptive buffer.
They're already there.
Adaptive buffer sizes. It's not. It's a simple matter of programming.
So the reason they're interested in QUIC is that it already has audio video friendly congestion control. If they're looking at the core source, they already see that in there. So it's like it already does everything they want to do, and they could go modify a user SCTP live, but they're games developers. They're not really interested in doing that. They don't even have the knowledge to do that. So that's kind of where they.
And a lot of the people asking for the QUIC data channel are people that have significant server infrastructure that's built around QUIC, and so it's very easy for them to.
They're already serving, they're already playing with HTTP over QUIC already, and already are using it. So.
And I would also echo what Martin said, that QUIC is still not baked. And a lot of people who want to do media over QUIC is to see if QUIC is worthy of doing media over it, and what changes need to be made to QUIC for it to be comparable. The RTP is not a transport, and it doesn't have like a congestion control that's been defined. There is the Google congestion control, and there are a few others, proprietary ones that everyone has. So I think a lot of people want to also look at QUIC and see if you'll have the same problems there or not. So there's no real significant gain as of now for doing media over QUIC.
I think we're going to need to wrap this session because we're already a couple of minutes over. Sure. But basically where we're going to go from here is, I guess we're going to create an RTP transport session. I'm not sure. We'll have to figure out when that goes. We have another session, the next session, right?
Yeah.
Which is about QUIC.
So the things I didn't cover that ought to be mentioned are, if we're going to allow SCTP data channels to work in NV without a peer connection, which I think is something people want. Right. They want to be able to continue to do the bottom middle box without SDP and a peer connection. We would need to have the transports from ORTC in WEBRTC NV for DTLS and SCTP. They're already defined. Right. And I was going to go over some of the details here. And then, of course, QUIC and RTP are things we already talked about. So the two things we didn't talk about were the fact that there are these two transports that we would need to have in WEBRTC NV in order to support the existing use case, but without doing peer connection STP. Okay.
So I think we're on to, what was the next?
Was it the use case one or the QUIC one? Maybe it was the use case one.
Oh,
we can.
Oh yeah, was the
switched if you want.
I'm confused about the agenda as we. Okay. Yeah, it's use cases. Okay. So.
All right. So
we have half an hour.
Slight change of subject. Yesterday we were talking about use cases, and I brought up the fact that if we split the RTP sender into an encoder and a transport, or a sender and an encoder, then a lot of these use cases can be done. Basically allowing the application to do more, in particular control the transport, make it go over quick, or the RTP packetization. And we talked earlier today about the end-to-end encryption. I think that the untrusted use case, or sorry, the trusted use case, the one where you trust the application, can be accomplished just by letting the app choose the RTP packetization, because then it can do encryption on top of the hop-by-hop layer, just itself in whatever form it wants to. But that requires the encoder to be split out of the transport. And there was a lot of discussion over whether that was worth the complexity introduced by having a separate encoder. So what I wanted to point out here is that if we don't have the encoder separate from the transport, these are the use cases that I don't know how we can accomplish. So the end-to-end encryption, we maybe could, if we have some kind of RTP sender dot set the extra key, but that would require having the entire thing baked into the browser, which maybe is the trade-off we want, but I think that allowing the app to do it would be a better option. And then we talked about the cases where you bring your own jitter buffer, FEC, or codec. On the right side of the slide are the use cases we've been talking about, where we want unified audio and video and data over a single congestion control context and protocol. And we can't do that over QUIC, at least, unless the encoder is separated from the transport. There is maybe a way we can do this with worklets, which I'll get to at the end of the day, but it's a random idea I came up with yesterday, so I'm not sure even if it'll work. So in other words, I think we should split the encoder out from the RTP sender, but there was a little bit of pushback yesterday, and I wanted to identify the use cases that I don't know how to do well without splitting out the encoder from the RTP sender.
So if we look at all of these, so we covered end-to-end encryption, and so let's put it out of the discussion. Jitter buffer, from what I understood, it's mostly a knob that you want to tune, and you want to add more or less jitter buffer. I think that can be done without splitting the encoder and the sender. Media over QUIC is, as Bernard said, it's also feasible without splitting the two. You just have to define somewhere a good mapping, which might take time, but might benefit everybody as well. So it has some advantages. Standardization has some advantages there, but we should not minimize. And it's doable. So it's not a hard requirement. It's just that there are two paths with pros and cons. So
bring your own FEC and codec violate the fundamental security invariance of the system once again. You can't let the app have access to the data.
What do you mean you can't
I had questions about the being your own thing. We talked about being able to adjust the FEC. We talked about being able to adjust the FEC in the RTX more, like more parameters. We actually have a use case that required creating your own retransmission. In fact, I thought, no, we didn't, did we? Okay, so it's the case where like your built-in FEC is satisfactory because and there's some you want to build your own and you can deal with the IPR yourself, and that was the case where you want to do that. Okay. Yeah, so that's what the case was, Ecker, where somebody wanted to add Raptor and the browser makers weren't comfortable with that because of IPR issues, as an example. That was I think the case for bring your own FEC.
Yeah, I mean, like we just have no analysis for how this is going to work.
Yeah, that's true too, but at least that was the use case, at least.
What
do you mean?
If you want to adjust the jitter buffer, there's no reason we can't provide a non-adjusting the jitter.
You know, having read the jitter buffer code significantly, like there's not one knob.
That's not one jitter buffer. It's not just the size of it.
It's much more complicated than that.
Yeah, I mean, I guess I'm not like super enthusiastic about creating like a whole pile of different reusable components, all of which have to be kind of glued together in some goofy way to make this work. Like if you want to write your entire web conferencing app in WebAssembly, go to town.
Well, the part that's missing is that, this is what came up yesterday, is that there's no access to encoders, in particular hardware encoders, but also performant software encoders, because WebAssembly on a video encodec, maybe not so good.
But if you're bringing your own encoder, you're going to get that situation, Peter. How's that encoder getting I mean, the encoder's going to be written in WebAssembly anyway.
So for audio, yeah, that might work, but being able to have a video encoder implementation available to the WebAssembly is what I would like for the go-to-town
But then
scenario.
it's in the browser, in which case you're back to the ordinary situation.
Yeah, I mean, where does this WebAssembly, where does this encoder that you're putting in that's performant and uses hardware and everything?
I'm saying if we took the RTP sender that we have, which has an encoder built in, we pull out the encoding piece and provide an API for that, which doesn't have RTP attached. It's like the encoding part of the RTP sender. You have an API for that. You stick in a track and you get out encoded frames. Then that would be enough for me to go to town, as Ecker so elegantly puts it.
But then you need to provide a lot of knobs to the encoder.
Not a lot.
Bit rates.
We went over those yesterday.
Yeah,
so if you want to do, if you want,
and I implement everything else. I go to town with everything else, but the browser implements the codec. That's the thing that.
So then you will need to introduce an H.264 codec with some parameters that are specific to H.264. You will need to introduce an AV1 encoder, a VP8 encoder, a VP9 encoder with different parameters that you would need to set, and so on.
This isn't that complicated. I've already looked through all the encoder objects we have in our source and the parameters that would need to be passed down.
This is exactly what we need. I mean, because we have huge problem to just try to specify, for example, the simulcast options or the SBC options, just because we tried. Not all codecs are the same. So even H.264 has different parameters. You can do different things on BP8 that on BP9. That in H.264. So having a single API and trying to wrap it in an RTP sender JSON object is crazy and doesn't work for most of the web developers that try to do anything else that just try to encode the video. So if you try to control any parameter in the coder, it's not possible with RTP sender. So also, and I don't like the RTP roles things, but I think that splitting the encoder for the transport in the RTP sender is really needed, because we have one use case that we can do at the moment. I mean, we can have one single encoding sent through two transport. You have to create two RTP senders that has two different encoders just to send the same thing over two different transport.
We can talk about this scenario. Usually when you have an encoder that is going to one client and another encoder that will go to another client, there will be two different bit rates. There might be two different frame rates, or you might drop some frames in one or the other. And I don't see how we will be able to actually have one encoder that will be able to provide a reasonable thing for both network paths that are very different.
That's what SVC is for.
And also, yeah, for example, if you want to use in a mesh scenario, you want to send your same video to a whole different participant, you may just use a single encoder and just to send to a.
Right. It's not exactly the same because the path might be different and you might send different layers to each one. So it might be the same input stream, but then the layers get dropped.
But you can do that with RTP sender.
We can also talk about SVC.
Yeah, there's a time slot later that's being done about SVC.
Okay.
Okay, so maybe we should just move over to the next set of slides, which is about Quick, since a lot of these are like, how do you do media over Quick, which is one of the reasons why I want the encoder split out. So,
can I just represent the peer-to-peer CDN use case for a second? So I have like three topics that I wanted to talk about. That one is prioritize data channels. So like first in line data channel signaling that will get first in line priority. Another thing is deprioritize data channels versus the HTTP stack in the browser. So for example, when sending back ACKs from an HTTP file, I want those ACKs to go first before all the data channels data. And the last thing is
Wow, so
more
like no
granular.
browser stacks in it. That's like really hard to do in the browser stack, I gotta tell you.
Yeah, okay.
I mean, and it's like not how like the browser stack's put together.
Well, just to clarify, is the data server, the data channel going to the same server as the HTTP or different?
No, it's going to peers. It's not
I mean,
going to the server.
even in like the hypothetical case where like this was all quick, like I don't believe any quick stack lets you be like, hey, like deprioritize this thing as opposed to this entire thing in this entirely different channel. It's not how like the stacks even like counting against congestion control window on quick.
Sorry, what?
I don't think Axe even count against the congestion control on quick.
Yeah. So the request here is at a very fine-grained level. What's the actual to control the fighting between the data channels and media versus the HTTP, etc. operations of the browser? That sort of thing could be mediated by the browser by lowering the overall priority of one or the other depending on what you're doing. I mean, basically giving having the browser reduce the amount of sharding it allows. For example, we have a certain number of sharding when you're loading a website. The use case I've heard in the past, and we've talked about but never implemented, is, for example, you have a media.
You're uploading to other peers in peer-to-peer, and I don't want the sending in through data channels will overflood the ACKs that are going back to the HTTP server.
Right. So the way you deal with that is you DSCP down the like the data which you'd like less, and let the network sort it out.
Yeah, actually, that might be one solution, but these are different 5 tuples, and actually you don't have so much control apart from like the place where you're uploading or sharing with the other peers. You stop those data channels from like you control it in your JavaScript by moderating yourself, because I don't think the stack would do anything, because it's I think it is fundamentally against net neutrality at that point, because you're like trying to change the behavior when you are totally in control of that behavior.
But
you
I
don't want something else to control that behavior for you.
But I'm not in control. I don't have a very fine-grained control of how fast I'm sending stuff in data channels, and that can easily overcome the bottleneck in the user sampling.
You do have your buffer on what you're sharing, like.
So maybe up level a bit. This is a discussion about use cases. We're getting a little bit into like how we would implement it. Yeah. Is it worth considering it as a use case, even if later we decide it's unachievable?
Yeah.
Okay.
And the last thing is stats everywhere, and more fine-grained stats. So, for example, RTT and latency, of course, but also if we can have the congestion control window on the sender or the scores, whatever, depending on the congestion control algorithm, having a more fine-grained understanding of what's going on right now.
Yeah, we've not exposed SCTP stats anywhere. I don't think there was any demand for it from anyone. Now that you come up with it, could you make a issue on WebRTC stats, on the stats you need from SCTP transport? We'll think of.
So a critical part of doing media over quick well is that the transport needs to expose an RTT and a bandwidth estimate up, and it's very easy to do that. So
yeah, we had discussed doing this and talked.
Defined so that 2 browsers who implement the same stat actually give the same number in the same situation, and the other one is actually that it's useful. So giving one scenario of one application where the application actually would change its behavior in response to measuring one or the other.
But then it's not a stat, right?
Well, kind of. One point back to the aggressive against HTTP. This is something that we should be a little bit careful about, because this is not the HTTP working group. And figuring out how stand different specs with different purposes and different web browser applications should behave against each other. That's a very good question, but it might not be this forum that is the right forum for it.
Right. And that was why I wanted to say, why did he want to do that? Because
yeah, so there's a protocol or a congestion control called LEDBAT, which is RTT based, and you could do scavenger. Like if that's what you want, then you could do scavenging, which is what BitTorrents did in the end. And I think Microsoft updates and OS updates happen over it, so that it doesn't interact with traffic.
Okay, so that was good to have anyone bring up anything about use cases before we move on. So does anyone else want to do that?
You didn't write the prioritized data channels against each other. So I want like a data channel that will be first in line against all the other data channels.
You already have a spec for that.
We've defined it. We just haven't implemented it.
The NData specification. So this is some, the NData extension.
And
will
the priority
take care of
spec.
that.
Okay, so in that case, I'll move on. So we'll talk about Quick. So the the Quick transport, as currently defined, is a thin layer on top of the Quick protocol that lets the app control how data or media would go on top of it. In the Quick spec, there are kind of two basic things.
I'm sorry, just maybe a point of clarification. What is the status of this document?
It's an extension spec that has not been adopted. Is that right?
Okay, that's what I thought. Okay.
Has been adopted within the WEBRTC CG. So
Right.
it's moving ahead.
Sure. Thanks.
So in the Quick spec, there are two main pieces, the connection and the stream. And we represent those in the API as a transport and a stream. I guess we could have called it Quick connection, but everything else in the API is called transport. So, but there's a very clear one-to-one mapping. And if the app wants to do reliable or ordered data on top of that, like the current data channel, then it could simply add a message framing into a single stream. Or if it wanted to have unreliable or unordered channels, it could do a mechanism of one stream per message. So both of these are very straightforward. It's like 10 lines of JavaScript or whatever. But if you just want to send like one file, you can do that as a single stream without doing any breaking up into messages. So
Just one comment though about the unordered. You're really talking about small messages here, because if it's larger than an MTU size, you're going to end up with multiple quick packets, and then the behavior will not be exactly what you see in a normal data channel, because
it'd be the same as with the.
Well, not quite, because Quick currently will retransmit, right?
Yeah, I mean, it's the same as an SCTP data channel, right?
Well, no, because you've sent multiple packets. So it's not, it's different if you send a small amount of data, right? Open it and then send a fin, then it's exactly the same. But if it's a little bit larger, you're sending multiple packets. And
Sure, so the unreliability here, I guess for unordered, yes.
Yeah.
Unordered but reliable, it's exactly the same. The unreliability can be achieved just by canceling a stream after a certain point in time. There isn't currently a way specified here to say only retransmit so many times or retransmit 0 times. We've talked about adding that, but it's not currently there. In order to send media over Quick, you need to figure out a way to take. So this is what Varun was asking about. You need to figure out a way to take an encoded frame that would come out of an encoder and stick that into some media stream or media streams. And to me, a really simple way of doing it is take the encoded frame, serialize it into a byte array, using whatever format you like, protocol buffer, CBOR, I don't know, JSON if you want, and then write that into a quick stream and do that 1 frame per stream. We've actually made a prototype doing this, and it works pretty well. So I think all of that's pretty straightforward. The tricky part in all of this is back pressure, which I have a whole bunch of slides on, but that's kind of like getting into the nitty-gritty detail. We should probably cover the basics here if people have questions about how.
I mean, so this is.
Go ahead,
Randall.
go ahead.
So here's what.
I'll let Echo go as soon as they're done. What's the interaction between the concern Bernard just was mentioning, which is if you're doing frame typically would be of many packets. What is the
you get the whole stream, or up until the point when you cancel it, or nothing.
Right, and so there'll be will retransmits happen unless you're like, I mean, the point is if you
what's going to happen is quick as it's defined today is a reliable transport. So it's going to take these 10 frames and keep retransmitting them. That isn't really what you want for that kind of media application. What you really want is something much. You basically want the options you'd have in the data channel today, which is like max retransmits or max packet lifetime. I think there are proposals in Quick to do those equivalent things, but they're not on the Quick working group.
Yeah, if you want to transmit a single frame, you want to make absolutely certain it doesn't retransmit those. If you want to do it, you don't want the retransmitting on its own. And the same thing would apply to the equivalent of the unreliable data channels. So you'd have to kind of jump around in games to try to. Okay.
This gets in the Quick development process to be like, let us hack unreliable messaging together with like a combination of stream frames and cancels.
If you read the spec today, what it says is that it's really for the reliable ordered case, subject to further IETF work to enable the other cases that are done by the data channel. That's really
reliable.
What the spec classically does. Like
reliable unordered is also fine.
Yeah.
Right. So if you're reliable ordered, that covers.
In the case of audio, you have basically 1 packet per stream. Then,
but that requires you to implement the unreliable message transport.
Say a second after you send the audio packet, okay, cancel this, which means it'll only retransmit for that period of time.
Right.
There's no per count of retransmissions currently in there. We've talked about adding it, but it hasn't. It's not there right now.
Right. So this depends on non-existent Quick stuff or not yet existent.
I don't think it needs to be part of the protocol. I think an implementation of Quick could just limit the number of retransmissions.
No, but this goes back to what I was saying. Like it's not like this is not how like streams are supposed to work in Quick.
Yeah. Well, also if you think about it, say you were doing.
What do you mean this isn't supposed to?
Like
yeah, because remember the problem is like for the case that Randall just said, where the frames got split into 10 packets. In theory, to get the exact same behavior as a data channel, I would need to keep opening and closing connections. Well, because if I don't want to have this retransmission occur on its own in this, within the quick stream of these 10 packets, I would need to essentially packetize it myself and open a different stream.
Streams, yeah. You say connections.
But the problem with that is, say I'm trying to transmit multiple streams. Now I somehow have to understand the mapping between the connection IDs and the streams that I'm sending and maintain that. I'm sending there's 2 video streams coming in or whatever. I'm getting all these new quick connection IDs for each.
So for that
packet,
you just need to add an ID in each stream of your own.
Yeah, you'd need to. I'm just saying there's a protocol format issue here that somehow I would need to handle myself to map the connection all these zillion connection IDs I'm getting into
stream
equivalent of SSRCs.
Right, so, and we've built a prototype of that, and it works really well.
Yeah, but you didn't make anyone else implement the same thing to see if it would interoperate, right?
Well, there's nothing to interoperate with.
It's the same. It's the same code on both sides, but I'm just saying there's some complexity there.
Right. So
and as we slowly from the ground up re-implement RTP.
So one thing
this is something that can be done, and if we have a quick transport the app can do it.
So just to say, like there are many strategies that you could do here. As in the one that you've taken is probably the most common one that people would do is put a frame onto a stream. But there are other reasons for people to put a whole picture, like a length of pictures, all associated frames onto that stream, right? And actually that's where, and none of the discussion is about that. The thing is that that needs to be defined somewhere, or some people need to like think about how they want to send media over it. And when you said that you can cancel a frame, you also have to have all the metadata associated. This may be a manifest file which you get separately. Which
No. It can just be in the stream.
Yeah, or something to say that this is a structure of connections or streams that are going to come, and the streams are related to each other in a certain way, which becomes a data structure problem.
But I think that we are discussing about things that are really irrelevant, because if I understand your proposal correctly, you are just proposing an abstract of the quick transport API.
Yes.
That may be used by someone to send data, to send media and video, but we don't have to solve how they solve it, because the API, the API is not providing anything concrete for audio or video. So if someone is crazy enough to try it, okay, but it doesn't mean that we as WebRTC need to solve it, because as I see it, he's proposing something that could be used to send audio or video if he has the encoder. But I don't care if it doesn't work, because this is not, we are not proposing a media quick stream. We are proposing a quick stream that is able to send something.
So
and something may be audio and video, and it may work.
So my concern here is that we would probably need a few more knobs, because the reset cancel might not be sufficient. You might need some more. This might be just that there needs more metadata or stats coming out of this to be able to make this workable. Because if I send a group of pictures on a stream, my behavior, then we come back to the question, like, I need more fine-grained control over what is happening on the quick stream. And if you're it's a short-lived quick stream, that if I send a fragmented packet of a frame onto a quick stream, which means you would have gazillion streams, then this is perfect, right? Because I would not even have to reset, because I could just use another
So just let me describe, if you go back one slide to the transport. So the key thing is there's this create stream method here. Currently has no argument, because there's only one thing Quick can do, which is reliable. So there's nothing to put in there. But in theory, if you had all these other things that it did, like max retransmits, you'd have more or less the equivalent of whatever it's called RTC data channel on it, would basically go into that quick stream argument, and then it would say, okay, create a stream with these following characteristics, you know, but you'd obviously need a quick spec that tells you all the things you can configure.
I just want to put a caveat to say that this is experimental and there's a lot more work to be done here, but it's a good start, because if
the
I want
spec
to
actually has that caveat in it.
So in building on top of this, basically and experimentally, the one thing that we found that we needed that's not here is the bandwidth estimate value coming out, which is what we talked about earlier.
So I've got
everything else.
Question about the certificates. How do they relate to the DTLS, or is there no DTLS?
It's basically the same.
Yeah, it's basically the same, but DTLS isn't involved here because it's a quick protocol instead. But it basically works the same way. You need fingerprints and, you know, the whole verification. And all
so if you're using a quick data channel and RTP for your media, then you do two different key exchanges. Where does the encryption key for the RTP media come from?
So if you
DTLS SRTP is today, it doesn't change.
Okay, so you do two separate key exchanges.
Yes.
It is possible to extract a key from the quick handshake and use that for RTP, but that's not something that
this doesn't assume, because this doesn't cover audio video. It doesn't assume quick SRTP or anything of that nature. It's just for the data.
So it's theoretically possible. We didn't think it was worth specifying that.
This looks interesting.
What is interesting?
Proposal is interesting.
Oh, okay.
But that also means that the certificates aren't necessarily the same. Like your quick server could offer you a separate set of certificates from your DTLS server.
It's like if you had two peer connections or two DTLS transports.
That's fun.
Oh, that doesn't seem very exciting.
Oh, the certificates are passed in the constructor, so they can, you get to decide what certificates you want to give it, right? You could create new ones.
You do, but the server, the DTLS server might give you different certificate
those are
from
the
the quick
remote-
server.
Yeah, but you pass those in also.
It seems much more reasonable to think about this. It seems much more reasonable to think about this as two unbundled DTLS connections than it does to think about this as two pair connections. And so if it were to exist at all, it should have the same constraints as that situation, which is to say uniform certificate blocks or fingerprint blocks.
So I think it's interesting as a proposal. The idea that somehow you would be able to replace WebSocket with something that would have more features, more control there is nice, especially if we are able to reuse an existing quick connection between the server and the client. So that sounds interesting. So there will be another topic, I guess, about how would look like this API. That's another topic, but at that level, that's interesting. The slippery slope there is like use that for audio and video. It's putting a lot of complexity and a lot of potential issues on the web developer there. So if the goal is to expose that precisely for audio and video, I think we will need to help web developers with. They should not need that API level by default. They should have a more simple solution to exchange audio and video. They should not need to write JavaScript this way. It's great. This API might be great in some cases where you're using WebSocket in a game, and now you have that. It's much better. You control everything. That's great. But for audio and video, I think we need something something better by default.
So
it's the equivalent. What you're saying is it's the equivalent of thinking of the difference between an RTP sender and the data channel. You don't really, the data channel is not really the optimized API for sending audio and video either, right?
Yeah, so there are two different roads here. One of them is that libraries can provide this, and there can be different experiments with how to map these things, because there might be different ways you want to do it. A live broadcast might choose to use a single stream, whereas or might choose to use mini streams, and non-live broadcast might choose to use one stream, something like that. The other option is that one of these mappings becomes, the popular one, maybe CBOR over mini quick streams, for example, and that gets defined in either the W3C or IETF. And then you can do, basically like we have a sender object that sits on top of one of these transport objects. But
we would need more than, I understand the big picture, but we would need more to decide there. There are obvious concerns in terms of performances, in terms of complexity, and sure, you can build libraries, but they may get out of date. There may be things that you would have been able to optimize if it was the browser that was doing it. And now, since it's not done this way, you're screwed. So, but yeah.
Yeah, it seems like at the current moment.
That's what the spec says.
Yeah.
I just want to say it's very, very simple and very powerful. It gives you a lot of control. Like if you want timestamp, just add a timestamp. If you want subtitles, just add subtitles. If you want this to be synchronized with some event in a game, just add that. Like it gives you all the power. And if you want a more simple thing on top of this, is very easy to either shim it and like create something in JavaScript on top of this and use that, or standardize a more traditional way of doing this, where the implementation is basically just a shim on top of this.
Yeah, those are kind of the two paths.
From a browser implementation point of view, you just do this. So my question.
Go ahead.
Sorry.
Go ahead.
Yeah, my question would be just in terms of the unreliable thing. Like, okay, you can create the stream and then cancel it, which.
Right.
Even if you're creating 1 million streams, it's so simple that there's no handshake. You just, here's an ID. So the fact that there are different streams on paper, it's very easy to make sure that they are the same stream from the application's perspective. But when you send something and then you cancel it, does that mean that the other endpoint will always send an acknowledgement back, or like how hacky is the unreliable thing, or is it good for that?
Yeah, I mean, if you're implementing for,
this is sufficient. If it's number of retransmissions, then this is not sufficient. And
I'm just wondering about the overhead of you're sending audio and video and you're creating 1,000 streams.
Oh, there's
even what you're saying
of having many streams.
What you just said is not true, because the effective canceling of stream is not to cancel retransmissions. It's to send RST stream, and now you have a race condition between the delivery of the data and delivery of the RST stream.
What
happens if you cancel it?
That was filed as a bug against the spec, understanding exactly what happens in that case.
I mean, this goes back to the very beginning. If the desired target is message-oriented transport and unreliable message-oriented transport, then those things ought to be part of like first-class things about Quick, not things we half bake in by creating by screwing around the stream cancellation interface.
Yes,
there already is proposals for this. It's just a matter of there's they're behind. They're in standardization behind getting HTTP done.
Right. So there are two proposals that I'm aware of inside the Quick working group that would be useful here. And as you say, those parts are certainly not baked. But in a future where they do get baked, it would be very easy to add support for those here. So for example, there's the proposal for having unreliable messages up to the size of an MTU, and it would be very easy to add a send unreliable message to the transport object here. It would be one method addition. There's also one for breaking up a stream and having chunks in it and having the different chunks be unreliable. And so we could add support for that to the Quick stream. But what we can provide an API for now is the more baked part of Quick that's available now. And then as time goes on and things become available, we can add them to the API.
The other thing that's missing, which I've heard an interest in for that unreliable case, is basically being able to use the data channel API. And there you need kind of an establishment protocol to be described that would run over, mostly I hear interest in it for the unreliable case where you just use the existing message API. So that work would need to be done as well on top of this to enable that particular use case.
Okay, so up-leveling a little bit. The one big question we have is whether we adopt this document. If we don't,
is this even in Charter?
Well, what we're doing in the face-to-face for NV is to figure out what it is that we're going to bring on.
It's not in the old charter, if that's what you're asking.
Is it in the proposed new charter?
Yes. Not explicitly described, but that's what you objected to, Ecker.
No. Let me clarify. So it's in scope of the charter. It's not a listed deliverable in the charter, but it fits into some of the description, and I think it would fit into the existing charter. Your objection or Mozilla's objection to the charter was about the liaison with Quick, which you can interpret as saying, let's not do this work for now. But I believe that it would be in scope for this group.
I'm looking at the proposed charter now.
Okay, so if we say yes, then we can continue in future meetings to discuss the fine details. We got a lot of stuff we could talk about, back pressure and buffering. If the answer is no, then that work will probably keep happening in the ORTC community group, and then just like NV did for many years, and then at some future day we'll pick it up again.
Yeah, I think this is far more big.
They're largely interested in this reliable kind of file transfer use case because they already have alternatives for the other thing. They can use the SCTP data channel for the unreliable. A bunch of them want the RTP thing. So I don't know that they're not. I haven't heard a lot of people waiting for the unreliable for using this.
So if you're only looking,
being able to transport data over Quick is like the #1 thing people have been asking us for.
It's mostly reliable, right? That's what.
Yeah.
Yeah.
Reliable, but potentially unordered.
But then why aren't you making it look like data channels? This is just goofy.
They don't want to have SCTP on their server endpoints.
I didn't say that. I said, why aren't you making it look like data channels?
Huh? We're not. This is not making it look like.
No, why aren't
not?
you?
Why aren't we?
Yes.
Yeah.
For the reliable case, it could be you could shim data channel on top.
Right.
But you'd have to define
okay,
a
so
protocol,
that's the second question. The first question is whether we have a quick transport at all. You moved on to the second question already.
Okay, well, so I think it should be clear. I think this is premature and should bake in the WEBRTC working group for quite some time until quick is word on ITF.
And I agree.
Requirement for NV that can go for a long period of time, right? Can we divide that into 3 different questions? Who doesn't want it at all forever? Who is okay to put it now, even though the underlying implementation is not ready and we're taking a risk knowingly? Or who is okay to not say no, but say maybe and revisit that depending on the quick update? What I'm afraid of is that we say no today and then we cannot revisit that later, right?
And to be clear, if we say yes, it's not like everything here is written in stone. It just means we get to talk about it in future meetings and continue to consider it part of the picture.
So there's also the question about priority. There's one priority, which is to finish WebRTC 1.0 in terms of implementation and in terms of specs. So there are still issues to be solved, and these are high priority. And this work has a lower priority.
Well, NV has always been lower priority than 1.0. So this is just in the scope of NV.
Right, but if we adopt it, then we might take still some time from the WebRTC 1.0
when I say adopted, I mean is part of the NV set of things, right? Which are all together lower priority than 1.0.
Okay.
Just like the ICE transport, DTLS transport, SCTP transport.
So I'm inclined to say we adopt the use cases. Like there's a bunch of interesting use cases that have come out of this discussion of things that we want to try and achieve. And we should be adopting those, and we should be adopting Quick as a potential solution, but with no timescale on it. Because I don't think like what I'm hearing is that people who would have to implement it are nervous about when that could happen. So I think we should
What do you mean by have to implement?
But we should be splitting out we accept the use cases. These things need solving. That should definitely go into MV. We should put a more nuanced gesture on knowing exactly what it is that we're going to do to solve that.
Well, I mean, in a sense, you're kicking the can down the road then. Eventually, we're going to have to answer this question. And
So
okay, it's an eventually answer.
I want to comment. I think I'm hearing that the approach to doing reliable data over the current draft of Quick is fairly baked and fairly much desired. The people who intend to work on this are not asking for permission, they're doing forum shopping. So the question is this working group's mailing list and trackers an appropriate forum for letting the people who are going to do that work anyway do it or not?
No, I don't think it's quite that simple.
I'm not finished.
Okay, sorry.
There is another part, which is the unreliable stuff, which is needed for the media stuff, that actually requires consultation with IETF work on Quick, I think, to figure out when it's appropriate and whether or not we should attempt to glom something onto existing functionality, or whether we should cooperate with Quick, which is why we should have a liaison, and make sure our requirements are heard when Quick adds the appropriate functionality. So that might be future work. But my opinion personally is that there is a core of work here that is fairly well baked, and that we should adopt it as part of the NV work.
Are you now finished?
I am now finished.
Perfect. So
Can't
this
see
is
me
not
gesturing.
this is not merely a matter of where the forum happens, because adoption implies endorsement by the working group. And so I'm perfectly happy to have this discussion continue to happen on this mailing list. That's a different question, since I can just filter it out. But it's a different question of whether or not it's being endorsed by the working group.
Yeah, it's not clear to me what endorsement and adopting really means in terms of process. Or
I wasn't.
anyway.
I was not being precise with the word on the slide.
Okay. One thing to note though. So it might be right that one part of the API might be stable. At least the underlying quick features might be stable, and we might want to expose it. But if we do not have a good idea of what is the actual end goal and what is the actual feature set that we will have, in particular the unreliable use cases, then we might have an API that is not consistent, because we would have shipped something that would go well with reliable, and for unreliable it will be a bit odd or not perfect. So that's why it may be fine to work a little bit in advance in terms of standardization, prototyping, but in terms of actual shipping and in terms of actual recommendation.
There's a long time between now and CR.
Right, but so that's why the adopting thing, it needs to be precise a little bit, I guess.
But implementations and ship.
We start working on this. What is the problem we're actually trying to solve here? Re-implementing the data channel over quick for what purpose? I totally get the part where like you want to do everything over quick, but I think that has the dependency on the IETF solving the unreliable sending over quick first.
We can start work on the things we know how to do now without having to have the entire picture. We don't have to wait till everything.
Can you do an explanation of what it means to adopt it?
Sorry, whoever's talking, can you be in the mic?
So Harold was asking for an explanation of what it means adopting a draft. So it doesn't have any meaning in the WC process. What we could do is to say, we think this is work the working group should be taking on. And if we do that, one signal we could send would be to publish a first public working draft. And we could put as many warnings and disclaimers as we want on this. Yeah, I mean, I guess that's basically the only signal that would match, I guess, this adoption principle. And of course,
it already has a warning in it, which basically says it's only for the reliable case.
So what happens if we don't do that? I mean,
very interesting, and it intersects with a lot of things that we're talking about. So I think this is the right place to talk about this stuff. And I think there's value in splitting up the encoder decoder from transport, then whether quick transport or RTP transport or whatever transport is the best transport. There is value here, and I think we should discuss it more.
So I have a question as well. If this is not adopted, so one reason to adopt it is that if Google would publish like behind a flag the experiment, and then there would be an API that we could all refer to, that would be a step in the right direction.
That's already happened.
Yeah,
that's already in the ORTC CG. So that doing it here doesn't add anything.
So the work on implementing this is already underway. So
okay. So the question there was if people wanted to build stuff on top of the experiment behind a flag,
right?
And if there's an API documented somewhere, if that would be
already documented
in ORTC. Okay, at least from that perspective, it solves that position that it's documented somewhere and we know how to track it. Because if you would change the implementation, you would at least flag it and say that this is now dated this version of that draft or something.
Right.
And I
Yeah. So
guess-
this is already in the WebRTC-Quick spec inside of the GitHub repository.
Part of the question, I think, is whether this working group wants to be hearing the early feedback from developers on where and how they would use a quick stream. If we think this is better handled in the WEBRTC CG, then it's probably best not to adopt this. If we think it's best that we all get exposed to that early input, then it's probably best.
That developer feedback is harder to bring here because they aren't members of the W3C, and therefore they can't join this group.
Well, joining is not required to raise issues, comment on issues, and so on.
So the main difference might be the legal framework between a community group and a WC working group. It's exactly the same.
It's not the same. It's not. In the community group, it's a contribution-based licensing agreement, whereas in the WCC, anyone who is in the working group gets committed on a relative basis for the whole specification, at least for what ends up in the recommendation for the given specification. So it's a much stronger commitment in the working group.
But that only takes effect once it reaches much later stages, right?
Okay. I'm still a bit on the verge, so I haven't
remember,
my mind there.
We're just asking the first question whether.
But I know that I want the working group to continue hearing about it and at some point to work on it. I think that there are great use cases there and potential. I don't want the working group to be distracted by that kind of subject. So it means that if there's an entering meeting, then if it's in the scope, then we are stealing time. So that's the kind of issue I might have there.
So one concern I have is the signal we're sending to users and browsers who still haven't implemented 1.0. Like I keep hearing, I've heard several times now, oh, we don't have to learn transceivers because transceivers will be, let's just wait for next version. Is that a concern? So that was one thing.
But that's like an NV versus 1.0 topic. That's not really quick specific.
Okay. The other thing, if we adopt this, no one's actually commented yet on the actual API that you showed. Was that just an illustration, or are we talking about plopping that into?
So we're talking about whether we're going to spend time talking about those, right? But first we need to decide that we're going to spend time talking about those things.
But if you're going to drop that WebIDL into a working document that the working group is going to support, I have a lot of feedback.
Good.
Like we should not expose
would you support taking time to talk about those things?
So
top end via emails, and maybe filtering could be applied.
It's still time. You can't just sort of like partition your brain and
Be clear, the discussion currently is happening in GitHub, and the issues, there is an editors meeting happening, and the issues get discussed there. These issues are not brought to the working group because it has not been adopted. So if you're not going to work on it, then you're not going to see the discussion of it. Because right now it's not an item of the WebRTC working group. So that would be the first decision to make. The discussion is occurring, but not here. If you want it to occur here, then you can.
I'd be happy to discuss this once we have
which is justified use case, but I would argue that browser vendors have even more end users that are doing data channels not for media purposes than they do for media. So that's another use case to think quick about, and it's not requiring unreliable.
So I would interpret what you just said is kind of what Harold said earlier. The use case of reliable is worthy of itself, even if we don't have a perfect picture of unreliable at the moment. And it's high priority for you. Yes, thank you.
Can I mention another concern maybe, which is I'm a little bit concerned that development on STTP-based data channels stalled completely because even the current situation is not bright in that regard. So what I'm saying is I don't want Quick to be an excuse to not implement STTP-based data channels.
I think that's totally valid. You know, earlier one of the slides I had was to say, okay, we should adopt an SATP transport in V so you can set it up without a peer connection. I think that is something we should support, and I think we should continue to have time like you have later today to improve on the SCTP data channels. So
Yes,
I think we can do both.
And from a point, and speaking to the time aspect again, you know, several of the things we talked about are issues where it's simply implementation issues, the buffer sizes and so on, because we're busy.
So another thing to point out is like this API is not that complicated. It's very simple. Other than the buffering, I'll get to that. And I don't think we're going to be spending a whole lot of time talking about it. It's not going to be a huge time. I don't think it's going to be a big time sink. It hasn't been in the work in the ORTC community group. So now, a caveat there, if we start defining how to do media, then yes, we could spend time. That could be a lot of time, but that's not what we're talking about right now. We're talking about reliable data channel technique.
So, I mean, this discussion sort of dovetails with us finishing 1.0. I mean, if we'd addressed it as a different point, is there any appetite for, I guess, absorbing Quick into existing data channels in some way more?
Within peer connection?
I guess, have we all decided that we're not going to do peer connection anymore? I mean,
all peer connection is going to be around for forever, indefinitely, right?
Yeah.
So, I mean, we've seen
It's
a lot
very
of
hard to get rid of things
that start anew from the ground up, and that seems to be one way to solve the issues that we've raised. Another one would be to try to increment more on existing APIs.
So you mean create an RTC data channel from a quick transport or something like that?
Yeah, well, I don't have a specific idea, but
doing an RTC data channel on top of this modulo, the unreliable part, is very easy. The question is whether you can do that within the context of a peer connection and the ICE transport that's in a peer connection. And I've always thought that was kind of
And then there's also
crazy,
partial reliability, which would be quite a pain to implement, I think.
So just to the point of how it would affect existing work, my understanding is that people working on this, for example, Seth Hampson, are not doing anything else in the WebRTC working group, and so they're not distracted. They're essentially just focused on the quick stuff. And none of the classic WebRTC PC editors are doing any quick stuff, so they're not distracted by the quick stuff either. So it's kind of independent.
Right, but if this is to be a working group item, then we will have to spend time on it, making sure it is good.
Again, I don't think it's going to be a lot. We're spending more time talking about how we're going to talk about it than I think we would actually spend talking about it.
That seems unlikely to me.
I think we will need some time for discussions, and it will take some time to get a proper definition and everything. So
I mean,
we should
point of order,
compromise,
like,
work there.
I'm not hearing consensus to adopt this work.
On our side, we're not yet ready, but yeah, maybe we can talk a little. Well, I don't know.
So if we don't do anything now, if in a year
adopted, nor are we seeing like endorsements either, but it's a good conversation. And if does it mean that if the working group decides not to adopt it, we will not have this discussion? Because this is a very good discussion to know what is the status and get an update of feelings of the ITF and things like that.
I think if we decide not to adopt it today, is the only discussion we would have on this topic later is whether to adopt it later. We wouldn't have a technical discussion on the actual shape of the API,
issue.
And I think that's a bit of a disservice because I do not follow the community group all that much.
Well, if you're interested and the working group decides not to, then you should.
Yeah, I mean, the problem is if you have to wait till the unreliable stuff gets done, as I understand it, that requires a rechartering in the quick working group, right? Because it's not on the current charter. So, and quick won't be done till December on the current schedule. So you'd probably be talking about like December 2019. By then, this will be out in the wild and shipped. So, you know, adopting it at that point and like starting to change existing shipping code is just not going to happen.
And isn't that the issue actually that we're feeling is that anyway it will be shipped, and maybe it will be good because everybody will have a very clear picture of which quick unreliable features will be available and the API will be correctly designed, or it will have been shipped and we will discover that the API is wrong, and then we will need to do like peer connection and work on fixing it and have a long tail of things, and people are unhappy about the API changes and so on.
Stupid proposal. Disclaimer, I'm not a browser vendor, right? So I'm not committing myself to a lot there. So take it with a grain of salt. I got the feeling that there is a specific small use case on the reliable case with actually consumer for it. Everybody that does data channel offload of CDN, stream route, peer 5, peer CDN, and so on. So people that are ready to test that today with the technology that is possible today. Is there anything that prevents some of us that are willing to do that to go ahead with that part and learn from there? I'm waiting for the possible case that happened in December 2019.
So that's already happening. It's just that it's happening within the context of the WEBRTC community group. And so there's a smaller group that's involved in the discussion.
So WEBRTC concept. Now, as a WEBRTC working group, is that something we want to prevent? If they want to port what they have done in WEBRTC specifically to that use case, with specifically the support of Feroz for WebTorrent and distributed Tier 5 and all those people that are show up today saying that this is important to them.
I guess the concern we've had is that adopting it is giving it some level of endorsement, and the working group only wants to do that if the working group as a whole spends time looking at it, reviewing it, not just saying.
I cannot remember precisely, but I remember of some cases in some groups where people said, we're okay to let you go ahead by yourself without committing as a working group yet. Please come back at TPAC and report on what was, for example.
I'm a bit surprised by this WEBRTC NV, because I thought WEBRTC NV was something that will come and we were building it properly and with a stable base. And it's not WEBRTC NV because maybe WEBRTC, this part will be shipped before we will finish WEBRTC 1.0. And that's kind of interesting to hear about. Like in 1 year from now, maybe all browsers will probably not have implemented all WEBRTC 1.0 APIs. And we will ship something else, which is WEBRTC NV and which should happen later on.
Much of what was discussed here shipped years ago. Like all the objects that were just discussed, SCTP transport, DTLS, all that stuff shipped years ago as ORTC. So you're correct that NV is what this discussion was about, was improving upon that, doing additional things.
As it shipped, do you have quick stream support? Because years ago, Quick was not there. So I don't understand how years ago you were able to ship a quick stream and a quick transport.
No, that's the new part. The rest of it, the RTP sender, DTLS, SCTP, all that shipped. It's already shipping. It's being used. Hundreds of millions of people are using this today, every day. Yes, we are. All of that, ORTC Live. No, ORTC Live shipped years ago. It's used by hundreds of millions of people every day. No, it's not just a browser group. That's the point. WEBRTC is much more than browsers. In fact, the majority usage of WebRTC is outside the browser.
So I actually have some clarity on what you're saying, Bernard. Are you saying that there are browsers that are shipping these APIs, or there's other things that are shipping these APIs?
Also, browsers that are shipping those APIs as well.
Which browsers?
But just to clarify this, WebRTC, this meeting was about things beyond what had already been done.
Sure.
This stuff's been out there for quite a long time.
Sure. I'm just asking which browsers.
Precisely to quick transport and quick stream.
So Edge shipped ORTC with the exception of data channel and the ICE transport controller and RTP listener. So that's been out for.
Okay.
This has not been out, I guess.
No, this is new, but most of the other stuff, obviously all the stuff Peter was talking about encoders and all that is new, but much of this has been out there for years.
Yeah, but of course, we as a group can't stop anyone from shipping whatever they like. But the discussion now is really about if this group would adopt this.
Yeah, my biggest concern about
No, RTP was not baked. We had to do so much work in ITF for RTP.
Oh, that's a fair characterization, but I think that
we adopted the documents and started working on that and started implementing it way ahead of time because we knew it would take a long time.
Sure.
Now
and
we're
what we
now
had was a partner in IETF to do the transport work. And that's exactly the point of concern here.
What transport work do you think needs to be done other than outside the unreliable part? If we're just talking about the reliable part, I don't see anything that's already not baked enough from the quick group.
And
baked
the
than RTP was when we adopted it for
right. But the unreliable part is the part I'm concerned about. Okay, you said
right. Or reliable use cases, right? It's like let's just scope it down a bit.
But the point is, we can work on it. That's fine. But in a year from now, this thing will have been shipped, and we will change. We might want to change the API just because of this unreliable use case.
Right, and that's
then
okay. We changed the WebRTC API like 100 times.
And then what will happen? Some browser vendors will say, "Oh, it shipped." And it's also good to get compatibility and keep the API stable. And so this will limit the scope of changes that we will be able to make.
So,
that's the way that the API for WebRTC has been all along.
Can you comment on what the current policy in Chrome for shipping unflagged and prefixed APIs with regard to the standardization process? I mean, I know there is origin trial.
I'd have to turn to the people that are more familiar with it.
Policy is roughly that there has to be at least a WICG draft that you can reference, and they look more at support. The people who approve look more at will this be supported in other browsers than they look at what stage of the standardization process is the draft at. They frown very much on shipping APIs that are not publicly documented. So the point is building the web platform, but waiting until the standards process has gotten all the T's crossed is not part of the release process.
Yeah, I guess what I was trying to figure is what impact adopting or not adopting this API in this working group would have on this API shipping in what ways in Chrome?
Would probably make the process a little bit easier. Compared to leaving it in the CG.
Can you repeat what you said?
It will probably make the process a little bit easier compared to leaving it in the CG.
Which process?
The process of getting approval for shipping this as a publicly exposed API in Chrome.
Even without any commitment from any of the other browser vendors.
Well,
comments from the web, the browser vendors would the other browser vendors would probably have more influence than the adoption. But yeah.
Well, I mean, Bernard
But
can
I
speak
think
for himself.
Bernard is
but-
making positive.
We have not issued an intent to implement, but Edge has not issued an intent to implement, but we are co-authors of the specs. So that as it becomes, as the quick protocol matures and everything, it's being considered very seriously. And we'll probably, it's not only being considered for Edge, but also for other products, particularly gaming.
Yes, maybe another way.
And
to
for
look at this
and
is
for that
whether-
game, go ahead.
Not in the short term. I guess I could be more specific. Is Safari and or Firefox considering shipping quick thing?
This is not on our roadmap anywhere.
No, it's not on our roadmap. I think there's consensus in Safari WebKit community that WebRTC 1.0 is a priority, and we should finish the implementation and finish the specs.
So I'm sorry to be difficult, but it's like now 2:30 in California. Can we like come to the conclusion of this discussion?
I actually don't hear consensus for adopting this draft now, and we will have to revisit maybe at the TPAC.
Okay, that means we cannot talk about back pressure and buffering.
I don't think we
can talk about it today. I mean, this is the purpose of this meeting. We come here for that specific reason about.
So we're going to discuss things, but not endorse the things that we discuss.
Discuss, but
we don't get consensus.
And we can't make decisions.
Regardless,
talk
I
about making
think
decisions?
due to a flight leaving pretty soon, we have to shift topic now to this
right
video codecs.
Oh, okay, right.
Well, although I would say that, so is Leonard gonna?
Yeah, Leonard has his time slot.
What did we do?
Oh, did we
ship-
eat up all of Leonard's
Because
time
that is
slot?
about back
No,
pressure.
we didn't. Yeah.
I thought it was a
still
separate
relevant
time
to existing data
Yeah.
channels.
So we're on for what's exactly is here now? Is it scalable video coding? Yeah. Okay, so let's slides are slightly out of order, but hopefully we'll find them in here. Okay. All right. So do you want to come up and I can present this part basically. So these are some slides that Sergio put together and talked about at 2 meetings ago, something like that. Was it TPAC? I don't remember. TPAC. Okay. Seems like only yesterday. And I guess, Sergio, you got some of this information from your survey of developers?
Yeah, and also experience about talking with the other SVU implementators.
Yeah. So basically, the simulcast and SVC use cases are pretty similar. When you tend to want simulcast, you also tend to want scalable video coding. Typically, today it's temporal scalability that's used, although VP9 has and AV1 have spatial scalability capabilities as well. So there's interest in that. Typically, the adaptation happens as a combination of some of the following things. You can adapt using bitrate. You can drop streams. You can adapt the image size, the frames per second, the quality, or the decoding complexity. We've had some comments about the current WebRTC 1.0 spec that some of these trade-offs are not entirely clear. For example, we have something called degradation preference, and it isn't entirely clear how it affects simulcast operation or SVC. We've had some comments on priority as well. But the basic idea is you've got a bunch of different clients in the same conference, and you're trying to adapt to the capabilities of each of them. And they may have different bandwidths, they may have different screen sizes or frames per second capability, and SVC can help enable that. Another use case described here is, I would say, differential robustness against packet losses, where you apply different protection levels to each SVC layer.
As an example, you might decide to retransmit or to forward error correct only the base layer and leave the only other layers to be lost because you can basically continue to, as long as you have the base layer, you can continue to send at least at some basic level of quality. So Sergio looked at some of the needs of application developers. I guess the first thing to say is there's an need to enable and disable temporal scalability in particular. That is something that is extremely widely used today. It's a flag in Chrome X Google flag conference. It's basically everyone who uses simulcast pretty much uses that flag, and it turns on temporal scalability as well. But it is not part of the WEBRTC 1.0 standard because that only covers simulcast. So that's definitely something that's extremely widely used today. There's also, I think, interest in going beyond. Simulcast is typically used today for spatial differentiation. And so there's an interest in the future codecs like VP9 or VP1 of having spatial scalability largely as a substitute for spatial simulcast. And then part of that is the ability to set the maximum frame rate or bit rate. Typically, you'll set that maybe on each individual simulcast stream. That's something I see interest in doing as an example. Set targets on the image size, like for example, you want the lower resolution to always be half that of the higher one, something of that nature. Varun?
Yeah, I had a question. How configurable do you think, how configurable do applications want their SVC layers to be? Are they?
Yeah, so in what we're going to get to that in a bit, but I think at least at a baseline level, I think we're talking about much the same kind of configuration that's available to simulcast today. That is, there's the scale down by parameter. Basically, the spatial simulcast is very similar to spatial scalability. It would be more or less the same kind of things that you would have for spatial simulcast. For temporal, it's a little bit different because there you're trying to vary the frame rate. And so at least in ORTC, what was done is kind of have an equivalent to the scale down by scale the frame rate down. Although it's a little bit different because in simulcast you don't have to scale the resolution by a factor of 2, but in SVC you sort of do. So it's a little bit different in that you could put in anything you want there, but really there's only certain allowable values.
Because I'm thinking in the case of SVC and even in simulcast that a lot of the people don't necessarily have like situations where the same device like typically downgrade towards a device by halving the resolution, but there are also situations because we have conferences with large number of people, there are devices with different parameters, right? So you have some iPhones and you have some iPads and sometimes when you want to do SVC, you want to have like not necessarily 3, but maybe 5, and you get different layers so that you can just transport, like take the first 3 and give it to the iPad,
right.
Take the first 2 and give it to the iPhone, and take 5 and send it to a large conferencing unit in a room somewhere.
You will probably set the maximum for some layers. Like for example, I want to send only at maximum this size and this field frame per second to the lower end feature phones or whatever. And you think if you want to do adaptation, you will just don't care about what are the intermediate. So
thinking more about like SVC where 1, 2, and 3 depend on each other or in some way.
Yeah.
But you could have 1, 2, and 4 and not necessarily depend on 3. So that was the configurability that I was thinking about.
So typically in temporal, it's kind of a hierarchical configuration where 4 depends on 3, depends on 2, depends on 1. But in terms of Sergio's survey, so I followed up with a bunch of the developers. What I found was the most typical configuration for VP8 at least was 3 simulcast layers and 3 temporal layers, which is more or less the default that you get in Chrome with the X Google conference flag. I've also seen some developers using 2 and 2, but 3 and 3 people seem to like because it covered like the vast majority of use cases. I didn't find a lot of developers using more than 3 by 3. And they actually liked the simplicity of just turning on the flag and letting the browser do something. And most of them didn't ever see the browser do anything objectionable, and they didn't really care to, like I asked people, do you want to configure the algorithm? Like, as I understand it, Chrome will drop the simulcast layer first, get down to the lower resolution, and then start dropping the frame rates. I said, did anybody want something different? Basically, people said, yeah, that's fine. And they didn't, because the question was specifically, does degradation preference change that? And people said, I hadn't thought about that, but I don't care. So there's not necessarily a lot of need for configurability. People seem to live with this, flag. It seems to do everything they want most of the time, and they seem happy with it. But anyway, kind of going down the list of things, setting priority between encodings and layers, so you could maybe you could mark them differently if you want to do that again. Then I think the list here would also be, for example, applying different protection, like having RTX occur on a base layer or FEC on a base layer, but not on other stuff. So those are the kind of things people do. So so those are the application div. The other side of it is that I think we haven't maybe paid enough attention to are the developers of the SFUs. So that's a whole nother people developing these kind of conference servers, right, that we hope will work with WebRTC. Many of them, they have their existing application that it was developed for. They're not necessarily that interested in changing their SFU dramatically to work with WebRTC. So they like when WebRTC works the way it currently works and doesn't change radically because it'll work with their SFU. So as an example, most SFUs that I know of seem to react fine to the existing Chrome behavior. It's kind of what they expect. There are a few, so as I mentioned here in WebRTC 1.0, some of it's undocumented. For example, we don't say how the algorithm for dropping is affected by degradation preference, priority, or DSCP markings. I'm not sure that it is, so we might end up saying it doesn't have any effect, but there's a little bit of uncertainty there.
Just to interrupt, I'm not even sure if there is priority or DSCP markings for layers or simulcasts.
You could, right? You can, in the encoding parameters, you can set the
DSCP parameters?
Yeah, actually in the encoding parameters, there's a lot of individual, for each of the individual simulcast layers, you can set a lot. You can set max bit rates, max frame rates. I'm not saying all of that stuff is actually engaged in implementations. I'm just saying it's there.
Oh, sure.
But for the purpose of developers, they might like to know, hey, is this stuff expected to do anything, or is it just a knob that I turn just for my own enjoyment with nothing else, nothing actually happening?
There are a lot of
right?
placebo knobs at the moment, which I myself do not know if they actually are implemented or something like you said and nothing happens below.
So part of the issue is that the spec just isn't well enough to find saying what, because if you think about it, if you're a browser implementer, there could be a million things you could be expected to do as a result of this API. And are you going to do all of them? I suspect not. But so we should make it clear what's not going to be, what we don't care about, or what shouldn't happen. Anyway, the other thing that I've heard a complaint about is the browsers will by nature drop layers. So say the browser's sending simulcast, but the bandwidth isn't there, it'll stop sending the top layer, the most high resolution layer. And the SFU is sitting there and starts seeing a stream disappear, right? There's no more packets. That could happen just because there's horrendous packet loss, or it could become because it was an intentional drop. There's no event that would allow the browser to say, hey, I dropped this, and so you could signal to the SFU, hey, not here. So very often people's code has to wait and say, particularly if you think about it, if you drop the highest layer, there may be some users downstream who are getting that layer. So now you have to do a stream switch. So I'm sitting here, I have nothing to send that person. If I knew that it got dropped, I would probably send an FIR to say, hey, give me the keyframe of the lower res thing so I can switch there. But I'm just sitting here waiting, hey, the stuff might show up. So it causes glitches in the video. That makes sense?
It does, but I'm not sure if you want to do it either in RTP or anywhere. Why wouldn't you just do it in data channels by like browser throwing an event and telling the SFU?
Yeah, if you had I'm just saying we don't have an event today, which is why you can't.
I would not want to do this in RTP because it has, it makes my head hurt already.
Yeah, so.
And it gets even worse because.
Many don't. But anyway, so this is kind of a little pain point right here, is that there's no event.
I mean, speaking as an SFU developer now, I mean, every millisecond counts. So if I have to wait 200 milliseconds until the events go up, and I can send it to the SVU
Yeah.
to these processes, and I have to set a feedback to get an iframe. I mean,
yeah, the thing is, it can actually
acceptable.
be even worse than that, because you can be sitting there depending on the RTT. You might wait a couple RTTs saying, "Hey, is this stuff going to show up?" You know,
when the layer drops, I go to get an iframe, so I can switch automatically. So I don't know why they have to.
But I don't see how you would solve it without putting this data either in the next RTP, like in the next layer that, you know, layer 2 tells you there's going to be no layer 3, and then it keeps telling you that, like it comes into the bit stream of the RTP packets. But if you do it in RTCP, it is unreliable. It can be lost.
It can be, but it may not. So,
so just as a little bit of background, so there was
RTCP timing rules. You cannot send RTCPs like at any given time.
Yeah. So I don't want to. The purpose of this presentation isn't to argue about how you would fix this problem.
Yes.
It's just to say there are these problems. Try to get consensus about what we want to fix. So the next question is how should we deliver SVC support, assuming we care about it. It is widely used. It is important to understand that different codecs have different capabilities. For example, VP8 has temporal scalability. H.264 ABC doesn't really have anything because it's ABC. And then VP8 and VP9 and AV1 have both temporal and spatial. So might be nice to support all of those if you're going to do it. In terms of options we have for WebRTC 1.0, it could be feasible, depending on the group's inclination, to have an extension to support temporal or spatial, and we have some idea of how that might work. It's basically extending the encoding parameters to allow dependencies on previous groups to signal SVC layers, and then in WebRTC NV, we've been discussing all of these different ways of doing things, encoders, and but it's also possible to do the same kind of things that you could do in 1.0. I guess the point here is that this potentially applies both to 1.0 and NV. There are a lot of people doing temporal scalability today in WebRTC 1.0. There are new codecs coming out which will have new capabilities. And so it would be a little odd if AV1 came out and was shipped in WebRTC 1.0 browsers and people couldn't use the spatial SVC that was there, at least in an easy way. Yeah.
So on the first bullet point there, the basic functionality based on encoding parameters, they're really just one or two, right? The dependency.
Yeah, so we're going to get into the discussion of that. The dependency encoding IDs is one approach.
Right.
We're going to get into a discussion of all that.
But the diff is fairly small if I...
Yeah, as they say, right? I think Harold said this. It looked like simulcast was such an innocent thing at the time, and then nothing is ever in it. Nothing is ever as simple as it looks. But yeah, in terms of parameters, it's small, but in terms of headaches, it might be large.
You're going to go over what the diff is.
Yeah, so we'll talk about some of these things. So so the first slide is on WebRTC 1.0. We can get into as much detail as people want or need, but I think the main purpose of this is to try to get a general sense of direction from the group as, again, how high or low do you want to go. So for WebRTC 1.0, a basic way to extend the parameters was developed in ORTC. As I said, it's adding another encoding parameter. The trickiest thing about this was not the parameter itself, but some of the capability issues that Harold has already brought up recently for simulcast. So as an example, one thing we see in simulcast today is that simulcast may not be supported for all codecs on a given browser. So for example, some browsers may support simulcast for VP8, but not H.264. Others may support H.264, but not VP8. So, so there's a basic capability thing there. It's also possible, similarly, that some browsers, for example, might support only temporal scalability for AV1, even though it supports spatial, right? So you can't assume that for any given codec, and then there'll be a question of how many layers, what's the maximum layers that you support for a given codec. So there's an issue of capability, discovering the capabilities, both in simulcast and SVC of a given codec. Then, as Harold has noted, there's issues even in WebRTC 1.0 with simulcast as it exists today. What if you exceed those those capabilities, right? It said, I can only do 3 simulcast layers, you ask for 5. And I think the general direction, Harold, is that we should give you 3 and not create errors so that make your life miserable. And probably if that's the direction for simulcast, it probably more or less makes sense for SVC. And I would say overall, the feedback I've gotten for developers is generally simple is better. And in fact, most of them don't even want to deal with this at all. They just want to tell the browser to do whatever it feels is best. And obviously the browser knows how many layers it supports of a given codec. So it's like, hey, do the right thing and leave me alone, as opposed to trying to guess what it can do and having it do something else and then having to retrieve parameters and figure out what it did. Just, hey, go do this.
Application developers typically are not codec or transport experts, and half the times if they do start messing with those things, it's based on an incorrect assumption about how it works, and it actually makes it worse.
Yeah, the people I talked to did not feel at all guilty about not understanding the details of codecs, and they were quite happy with the behavior they were seeing and didn't complain about it. So anyway, just something to think about. And then, generally the way things probably would work within the existing WebRTC 1.0 framework is you'd have some kind of get capabilities. We don't have that currently. We don't have max simulcasts, but and depending on the behavior, you might or might not care about that. But that might be one thing to say. How many temporal layers you can get. In ORTC, it works this way: how many simulcast layers, how many temporal, how many spatial is the maximum, and then you'd have a set parameters that would set what you want, and subject to some of the PR issues that Harold is working through. If it's excessive, just do the maximum, and then potentially you would get parameters to figure out what you got. The other thing is just to keep in mind is that because people seem relatively happy with the X Google flag thing, that probably developers would be I suspect the vast majority of developers don't even want to deal with it at the level we've just described. That might, and maybe this is a JavaScript library that just says, hey, do some simulcast stuff, in default and just arrange it yourself. And that particularly for SVC, where some of the scalings are kind of predefined, I could suspect a novice developer would start to do weird things that, we could kind of go along the lines Howard suggested and have it figure out what you wanted to do. But if you're already kind of trying to interpret what somebody is saying, you might as well just give them a reasonable default to begin with, right? They might do things like try to scale the frame rate by a factor of 3 instead of 2, or, choose a weird, we've already had some problems, by the way, even in the existing spec, about being clear about what order the encodings are supposed to be in. So none of that really matters if you're telling somebody to do the right thing and they just do it, because then you're not getting into that level. But I think already, haven't we seen different browsers interpret the order differently? Yeah.
So what happened was that we had, when we tried to set the order using the API, we discovered that the examples in the spec were kind of assuming that you gave the layers from biggest to smallest.
Right.
While there was a line in the codes where there was the assumption that the encodings were given from smallest to biggest.
Yep. So those are some of the things to think about. And then, there's the overall question, which we already have with simulcast, is how much stuff can you, because it's in encodings like simulcast would be, how many of these different parameters do you allow to impact things? I mean, some of them probably wouldn't make a lot of sense. Like if you're doing, for example, temporal encoding, would you also put a max frame rate on there? Why would you do that, right? It's already got a frame rate scale. So there'd be a whole bunch of things we need to define as to which we probably already need to do to simulcast, what things are going to impact and which do not. So for WebRTC ND, I guess based on some of the feedback, maybe we're not going to do the video encoder. So it's more or less the same set of problems as I just outlined for 1.0, with some differences. For example, maybe you have set parameters and get parameters, and maybe you don't. it does, the nice thing about having set parameters and get parameters as we do in WebRTC 1.0 is it gives you the possibility of not throwing errors when somebody puts in an encoding that's a little weird. You basically decide what you think they meant, and then they can get the parameters and figure out what actually happened. Whereas if you don't have that, then you have the question about what did the developer actually get, and it's a little bit less clear. So I guess the overall question for the group is, I guess the first question is, do we feel that it's useful to specify, get into this whole SVC issue and support it? And if so, is this something we should do as an extension to WebRTC 1.0? Or is it something purely for NV? So I guess that's the main question on which we'd like people's opinion.
So currently, if we look at WebRTC 1.0, it's H.264 and VP8, which would mean temporal scalability only, right?
Yeah, that's the first priority. That's what people do today.
Or
simulcast, yeah.
Okay, I think that these things are in scope of WebRTC 1.0. To me, the rest is WebRTC NV.
You mean spatial scalability is for NV?
So, right, and all the AV1, VP9.
Well, VP9 is used today in WebRTC 1.0.
Can I interject here? Just because the 1.0 only requires 264 and VP8 does not mean that 1.0 does not support other codecs like VP9, which is already supported widely, like AV1, which will be supported in WebRTC 1.0. So the fact that the required codecs don't have spatial scalability does not mean that 1.0 will not have codecs that support spatial scalability.
Yeah, apparently adding simulcast to WebRTC 1.0 was, let's say, a decision that introduced some delay. Or
yes.
Limited, let's say, but anyway.
Some is being very generous, but quite a bit.
So introducing more stuff related to codecs that are not required in WebRTC 1.0 seems like.
Yeah, so just to be clear, this would be an extension. It would not be in the WebRTC 1.0 spec. We're not adding features at this point. And in fact, Harold has even suggested taking simulcast out and sticking it maybe in the same extension spec, because the same questions arise with SVC and simulcast, right? It's all clarifying exactly how this stuff works, right? In the model and all that. It's all the same bunch of questions.
Maybe the right distinction is not 1.0 post 1.0, but rather works with peer connection or doesn't work with peer connection.
Yeah, probably.
No objection on having it supported in peer connection.
Yeah, in fact, because of the things we just described with the set and get, it's a little bit probably clearer how to make it work with peer connection and with NV if you're going to try to do what I wanted rather than what I said. Because you have, in 1.0, you have get parameters, which could actually tell you what the browser did if it wasn't what you asked for. Whereas in NV, it's not really clear how you do that. So that, one proposal I would like to put out would be there's an extension spec. Harold has proposed it covered details of simulcast as well, because it's some of the same questions you would answer for SVC. So I'd like to hear opinions on that, whether that extension spec kind of takes some of the simulcast out, which would let that also mature at its own rate, which seems to be less than the rest of 1.0.
The main point of separating it out would be to have a one spec that changes as we figure things out, and leave the main spec in peace.
Yeah,
that seems a generally overall reasonable approach.
So let me ask this question. Is there any opposition to trying to prepare a proposal along these lines and let the working group look at it and see what they think? I don't think we're anywhere near close to deciding anything, but should we prepare a spec? Let it percolate? Okay. I'm hearing general interest in that. So, well, the next question is, what?
I'll take an action item on that.
What action item will you take?
To prepare draft.
Ah,
Draft
excellent.
PR.
We have Harold actually proposing to do the work. That's even better. Any other people interested? Sergio, I will help chip in a little bit as well. Okay, so Sergio.
But that draft includes both simulcast and SVC.
Yeah, I think.
I'm volunteering to do the draft on moving out simulcast, and then the SVC folks can
we'll add
help add more stuff later.
It's something we'll have to explain, but not. No. No, and removing stuff usually reduce risks that you bring to the web. So it can be.
Yeah, I mean, one of the things we would obviously describe to the group is what we're proposing to take out. I mean, what's in that spec, but presumably that's what Harold will be working through, and we'll add the SVC proposals in there. And then my third question is generally, what kind of SVC proposal would the group like? As I've described, there's a lot of developers who just want to basically say, go do the right thing. And, maybe tell me a little bit after the fact what you've done, but we're not really interested in specifying this SVC thing to an infinite degree. The average configuration tends to handle 90% of the usage.
There are a lot of use cases where the application wants very tight control.
So I guess my question to the group is kind of what are people thinking? Certainly one way would be to give them the infinite amount of control, and then basically you're giving the developer the foot gun, and you'll see a lot of bloody feet. Would you like some kind of default option where you say, hey, I don't know or care about this, but generally the default is fine with me, given what I'm seeing in Chrome, just go do that.
So,
like 3x3 is what you see today. A lot of people seem to be happy with that.
And the default would be defined in the spec and everything.
Yeah, default would be in the spec, like as an example, the 3x3, three SVC layers, 3 simulcast layers, go do that. That's a typical default today. People seem happy with it.
Basically, at least from an NV standpoint, outside of peer connection, are we talking about having like a generate default parameters for me because I don't know what I'm doing? And then
I think
pass that into the thing?
Yeah, I think we'll have to discuss more how you say I want the default. Well, yeah, that's kind of dangerous though, because somebody might not want SVC at all. They're just trying to do like a peer-to-peer connection, and suddenly they get 3 simulcast layers and 3 SVC layers. So you kind of you need some indication that you want the SVC default.
Right. I want SVC, but I don't know any more details beyond that. Give me something.
Yeah. So at this point, I'm just asking for general direction. We'll try to figure out how this ought to work. But is the sentiment that people want to have a default, not just the foot gun approach? Is that what I'm hearing?
Yes.
Defaults are good because most of the developers don't have any idea how to set them.
Yeah, and frankly, they don't want to. But okay, so direction is try to have some kind of reasonable default that's not excruciating to configure, but also provide the foot gun for those who really want to shoot off their feet. Okay.
Just to say that when we don't provide any control, the problem is that most developers do run into issues where they would suddenly realize that they need control, and this thing starts to escalate because initially it's only like a minority, and they say, oh, let's ignore it, and that minority starts to grow, and at that point they have no clue what to do. And as people that collect a lot of stats, we see these people reach out to us and say like, hey, how would we control something like this when we see something like this? And at that point, we have nothing to say but to say like, oh, this is the default.
But I do have a question now. I guess I noticed in the stats, and Harold and Bruin can probably say more, there was discussion about SVC stats, and did that generate stats on each layer? You don't have objects right now.
The person who asked for it came back 6 months later and said, I'm working on another project now, so I don't care
Okay.
anymore.
So it might be in this spec, we might need a few extra stats or put the stats.
Yeah,
in
last time we had a
spec.
discussion in a whiteboard. It like we could not agree what objects these stats would appear on and how would you make sense of them.
Okay. So anyway, that's an item as well. It's possible we might start configuring stuff for which we don't have stats, which wouldn't be so great, I think.
Just to say that people screaming at you and giving good feedback is great, so that you can improve later on the API. So
okay. All right. So I think we're finished with this session. So what?
Sorry, I have a question.
Yes.
So since we haven't decided whether to split out the encoder from the RTP sender or not, where are you going to put these on the RTP sender?
In WEBRTC 1.0, it would be
well, in 1.0 it has to be on the sender, right? But
yeah, it has to be on the sender.
I meant for the outside of
well, you know, I think that what we're described here is kind of more 1.0 centric. I think the first step, because the NV model currently doesn't have set parameters, get parameters, which as we work through this model, we might understand how useful that is. And it might be that NV might need to incorporate a get and set mechanism if to handle some of the issues that come up. So I don't want to. It would definitely go on the RTP sender, but exactly what would be needed to handle the not getting exactly what you asked for case, it still would remain to be determined for NV. But there is a discussion occurring there in the model. I think it's tending so far more towards the error kind of situation than it has in WEBRTC 1.0 because there's no get parameters to kind of determine what you got.
So if we split the encoder from the sender, then I suppose this would go on the encoder.
Yes, it would go on the encoder. Okay, so I think we're done with this discussion, and the next is Leonard.
One little interim. We screwed up with the delivery of coffee this morning. If someone's desperate, we have a place to lead them downstairs. But otherwise, it's lunch in 1 hour, so perhaps we just go on.
Okay. There was there, I guess. No.
Leonard, are you ready now?
I'm there.
Have you sent the slides to Bernard?
They're here, I think.
Yeah,
Oh,
yeah,
perfect.
these are all the slides here.
Take it away.
So can we make Leonard the presenter, or do I have to be the slide turner?
I think it would be good if you could, yeah.
Okay, I'll turn the slides. Okay, it's all yours, Leonard.
All right. So hello, everyone. This is about SCTP data channel and streams, and I want to talk about that. SCTP is the basis of data channels for quite a while now, and I want to look at things that didn't really work out and hopefully resolve them with evolutionary steps. I don't plan to do any radical stuff. Next slide, please. So these are the use case requirements I want to tackle. They are taken from the use case requirements presented yesterday. So let's go briefly over them. Back pressure on both sides, or we can also call it flow control, or it is also part of buffering. I'm not sure what the perfect terminology is. Maybe we can settle on back pressure. Control over retransmissions, less noise on the wire, having possibly a congestion control that works well with audio and video and SCTP as well, and reduce inertial RTTs. This hasn't been brought up yesterday, but it has been brought up on the mailing list a while ago. Next slide, please. So let's go directly into the issue of back pressure and buffering. Sadly, Peter didn't talk about it today, but well, I hope this will be a little bit less controversial, but we'll see. Yeah, we have an issue with buffering. So be aware all of what I'm going to present here, these three steps there on the slide are need to be done by the application, not by the underlying implementation. So if you want to handle buffering and backpressure, and if you want to prevent backpressure on the sender side, you have to set the buffered amount low threshold on the data channel to some carefully chosen low watermark value. And then you send messages until it reaches some other carefully chosen high watermark value. And then you pause sending. This is all done in the application. And you continue sending once the buffered amount low event fires. So this may be a little bit hard to get right, but it kind of works. The thing is that this only works under certain circumstances. So yeah, next slide, please. Because this only works if you don't send large messages. Keep in mind, data channels are message-oriented, so we can send large messages, and this is perfectly fine. There's a valid use case for that. So problem here is that if we send a large message, this will blow up the buffer. For example, if we send a large file. Next slide, please. Okay, so on the receiver side, it doesn't look that bright at all. The problem here is basically there's nothing in the API that allows us to control the backpressure to handle it in any way. If the sender is faster than the receiver, then just hope you have installed enough RAM. That's pretty much what the status quo of the API is. So, for example, if we send one large message containing a large file, then you have 1 GB in RAM on the receiver side when you reassemble it. And if you get a lot of messages, then you will have a lot of these messages queued in your buffer. All right, next slide, please. So what does SCTP offer us to fix this? Well, again, SCTP is message-oriented. So what we don't want to do is break up a large file into small messages and then add another protocol on top to mark the end of a file. What we want to do is we want to break up a large file into small chunks and then leverage the message-oriented principle of SCTP to mark the end of a file. So how can we do that? On the sender side, there is SCTP offers an explicit ERA mode, which allows us to send a large message in small chunks. And on the receiver side, I sadly have bad news for you. We can do some kind of flow control there. We can pause receiving the whole on the whole association, but that would mean that this would have to happen on all data channels simultaneously. So that is pretty hard to get right API-wise, and I'll hopefully come back to that. Next slide. So this is the quick and dirty way I could think of to resolve this. On the sender side, we could, add send some kind of object in the send call with the chunk, and then add some explicit EOR marking to say this is the end of a message or it's not. This would follow the internal SCTP API very closely, the C API. And on the receiver side, we could add a new binary type, for example, called array buffer chunked, and then hand out partial messages, these are the chunks, in the message event, and expose an attribute to the message event that marks the end of a file. Again, to pause receiving is tricky to do this in a quick and dirty way. But the thing is with this API is that this is pretty brittle because even some browsers, not saying which ones, still get it wrong as of today. So I'm not sure that's a good approach. Next slide. Okay, so let me introduce you to what WG streams. This is an issue that has been brought up a while ago, I think, a few months ago, on the issue tracker. So on the sender side, we could add a new method, something like create writable stream, and then you get a writable stream instance back. This is different to what we have today, because normally you would just send and then it atomically sends. But now we get a writable stream instance. And on this writable stream instance, we can create a writer. And every time you want to add a chunk to this message, we just call .write on the associated writer. This is, by the way, the low-level API. There's some high-level components I will talk about later. And once the writer has been closed, you can do that with a close method on the writer. You mark the end of the message, and then it's complete. On the receiver side, we could have a new binary type called stream, and then we hand out a readable stream instance as part of the message event, but the difference here with the first chunk received, not with the last one. And yeah, again, pause receiving is still tricky, but the difference here is that this model would allow us to add, if we have a way to do on a channel basis to do the flow control, we can add this later without any API changes. All right, next slide, please. So let's break this up in a little bit more in detail, because this can be a bit hard to wrap your head around. So essentially, each individual message is a stream. And on the left side, we see the sender side. Again, we create a writable stream, then we add chunks, and then we close the thing, and then the message is complete. On the receiver side, we get the message event, we read from it, and then it is marked closed at some point, and then the message is complete. Of course, the chunks, they don't have to be of the same size on both sides. So this is up to the implementation. And then this whole procedure repeats itself for every message on the channel. The thing is that there's a high-level API component of what WG streams, which allows us to, if we have more components using it, we can use the pipe2 method. For example, we already have the fetch API to make an HTTP request and get a response as a stream. And then we can pipe it directly into a data channel. I think that's basically what Tim showed us yesterday as a demo.
Leonard, some comment there.
Yeah.
Yeah, I agree that in the context of service workers, when you give a response, you can pass, when you create a response, a synthetic response, you can pass a readable stream as as the constructor, and it's working fine. And then it can be optimized if the source of the stream is actually a native stream, so that you never go through JavaScript at all.
Yeah, so, exactly.
And pipe2 would do the same. So fetch response has a readable stream. It's also true that request has a readable stream to upload data. So it's a readable stream and not a writable stream. So you could also change that, the create writable stream with set readable stream, basically. And that
yeah,
will,
I think
that will work similarly.
Yeah, I think we talked briefly about that in the issue. I wasn't really sure why they do this why they use a readable stream for that, but it would probably work in a very similar way.
Yeah, what I know, at least from our own implementation point of view, readable stream is pretty mature. The implementation is much better than the writable stream implementation right now, and there's no example yet of, to my knowledge, of writable stream backed by a native source.
Right. I think I think you're correct. The writable stream thing is not completely mature. There is the implementation in JavaScript.
In terms of implementation, it's not mature, at least in Safari. It does not mean that in terms of spec, the spec, I think, is quite mature for writable stream.
Yeah, the only thing that I think is missing from writable streams is the possibility to bring your own buffer. They haven't specified that yet, but that's something we could leverage later when it is being added.
Here's a question today of trying to build a blob with all the data that you've chunked across one at a time, because that's one of the biggest annoyances of the current API when transferring files. And it's also both a memory hit and a time hit because now you have to transfer the whole thing at once to disk.
That is a perfectly valid point. I asked yesterday on the IRC channel of the WG group. They said that they haven't done anything yet on that, but there is interest. So if the Streams API, which I hope it is implemented widely everywhere, then I hope to see a file API so we can write a stream directly to a file without having this in memory at the time.
Just to clarify, I mean, Randall asked if it's possible. Yes, it's possible. You'd get a reader, and then you can do it that way. I guess what Leonard's talking about, it'd be nice to have a stream API for that. So it'd be nicer.
Yes.
Yeah. Okay. And that would put some leverage, some pressure on them to do that.
I have a question. When I look at the WhatWG streams examples, it seems rather easy to implement a readable stream on top of other abstractions that have lots of examples of that. And they even have a theoretical example of back pressure sockets where if there were a socket, which looks exactly like a data channel, had a read stop method, then that could be a way for the receiver to provide back pressure. Would it make sense to turn their hypothetical example of building on top of a socket that has a read stop method and a read start method, and just add that to the data channel and then do readable streams on top of it, like the hypothetical example?
So it would be fine, but I think the goal there is to have a readable stream or a writable stream with a native source, so that you do not go through the whole JavaScript limbo of promise resolution and everything, and so that when you do piping, you can do piping from a native source to a native consumer.
Yes,
that's one. You want to avoid Java. Sorry, go ahead.
That's going to require more commitment from the browsers to spend time implementing that. Whereas if you just had this one method you would add, to be a lot more likely for a browser to be willing to implement it.
I believe it's already a thing with service workers there, for instance.
You're allowed to implement it poorly.
And I think of anytime you can avoid the main thread of JavaScript, you win.
Yes, there's of course the optimization win, but there's also another thing that the example they brought up in the WhatWG streams spec is not message oriented. So this is message oriented. We have a stream per message, but the example is based on they treat messages as chunks, which I don't want to do.
So one thing in this suggested API, which I like, is we don't have any means of the sender telling the recipient what kind of message is coming. So the recipient can choose to either receive it as a blob or receive it as a stream, which means that the stream is that the sender can cause all the problems that it can do today, also in this structure, right?
Yeah, you're correct about that. If we keep this the current API, which is this approach, then the streams is just an extension. So if I want to receive as a stream, I can receive as a stream, but if I don't want to, I can still receive it as a blob or an array buffer. But of course, usually you control both sides. So you know if there's someone who sends a lot of data, and then you will take the stream approach.
Usually we are having the same application at both ends, so it's not a problem.
Yes. Right. So next slide. Okay. So we talked about advantages already a little bit. There's of course platform consistency. If the Streams API is adopted more in web APIs, there is the advantage that we have low level and high level at the same time. So we can do this writing individual chunks and reading individual chunks, but we can also use pipe 2. Or we can also use transform streams, for example, unzipping or doing double crypto. And this can be optimized if the browser provides these kind of things. There's also the bring your own buffer concept, which allows us to, well, it is a little bit theoretical, but we could write directly into a buffer that has been provided by the user, if the implementation can do that. And that would reduce copying. Yeah, we talked that this we talked about that this doesn't need to pass through JavaScript already. Okay, so any more questions on the stream side of this proposal? Is there a general yes, we should do this, or no? Should this be in NV, or should we also backport it to 1.0? And something I would particularly like to see, if can we possibly say goodbye to max message size?
So I'll jump in and be the first to try to provide some answers. I think we should do this. I generally like the API. I think it should be in NV. I think if we want to do it in 1.0, part of the the wanting to finish off 1.0 and so forth, I think we should consider this as an extension spec, not as the part of the 1.0 original spec. But that I'm open to discussion on that. And as far as max message size, I would love to see max message size go away. And this actually provides largely the sort of large transfer, a better form of the large transfer stuff we had discussed and actually implemented in some cases before max message size came along. I don't know that we can get rid of max message size as long as we're providing the existing APIs for send. But it can be effectively if you suggest that anytime you're sending more than X, you should be using this instead of relying on max message size. The problem is, what is X? Is X max message size?
Don't we need to keep max message size for the unordered case anyway?
Probably. Well, yeah. It probably needed, like I said, it's probably needed for some of the existing API cases. This is not particularly targeted at any sort of unordered case, or for that matter, unreliable case, really. And so for those cases, you still need max message size, I think.
I think we need, if it's an extension, then we need to parse max message size, because we need to interwork with people who don't implement the extension.
I would love to get rid of max message size. I just don't think that we can.
So
and when we do sending and don't use this mechanism, there is a max message size that is visible in the API. So no, we can't get rid of it totally. It might change meaning, and it might only occur might be infinity in some cases.
Yes, so we could probably settle on, if this is implemented in the browser, it could announce 0, which is basically infinite.
Yeah, well, yeah, I mean, the real thing is, if you provide a 2 GB blob to it as an unordered,
Yeah,
as an
Okay, yeah.
unordered, unreliable channel. Okay. So to be ignoring the last question,
yeah,
I think yay, and I think NV and quite possibly an extension spec. What do other people think?
Yeah, I would think that for me it's yeah for both answers there. It seems very reasonable. There's the possibility to have some consistency between different APIs. For instance, if we allow such constructs in peer connection, then you can pipe some info from WebRTC directly to a fetch response, for instance, or you could try to do some things like that. And if there's more adoption of the Streams API elsewhere, then it's a good way to do things there. There are some caveats, and for instance, a readable stream can actually stream anything like cows, pigs, potatoes, which might be problematic in some cases. The fetch spec is a good example where they decided to restrict it to array buffers, which in that case makes sense as well. It's true that we should study BIOB before, like to go further. We should investigate this.
I think
there's work done to actually write the spec.
Yeah, I think that's a good point. We should probably restrict it to, binary only.
Sure, that's the details of actually speccing it out.
So if I can take a turn, I'll go bottom to top. Number 3, I don't really have an opinion. Number 2, I don't really see any reason that it would be NV specific. Doesn't seem like whether the data channel is attached to a peer connection or not matters. So just define it in terms of both, as far as I can tell. And number 1, I'm not opposed to this being spec'd out and standardized, but as far as priorities go, it seems like quite low priority compared to other things.
I think technically this belongs in 1.0. I mean, if we're talking about timelines, I mean, it's a nice incremental addition to the existing data channel. It's kind of like promises to me. It like should have been there to start.
So just to clarify, are you saying it should be in the WebRTC 1.0 specification?
I think logically that's where it belongs if we decide for time reasons. I mean, yeah, logically, yes.
Yeah, leave it in peace. Yeah, I think to me at least it was I saw it as extension, right? And also another point related to NV. So there's a model there. If we work on it and see that it's working well with data channel, we might want to reuse that same model in other parts of WebRTC NV.
Just a comment, which is that in the NV spec, the data channel is pretty much unchanged. So it doesn't really, saying it's only in NV, it's basically the same API anyway. Yeah.
Hopefully we'll be using, hopefully all APIs we come up with in NV will be using readable, writable, and not, it's kind of like you wouldn't add callback APIs in 2018. You wouldn't write buffer APIs either.
I would like to see that too, but I think this will be controversial at some points. So, any more comments on that?
You were asking a question, Lennart. I think we missed it.
Did I? I was just...
He just said any more comments.
Yeah, any more comments? What's the question?
So do we have consensus to look at this?
So So what I hear is that we will start an extension spec for this. Lennart, are you volunteering?
I could, yeah, I will try to do that, but I'm a little bit time restricted at the moment. So I could definitely use some help.
So Leonard said he might be a little busy, which
Yeah.
implies that he needs additional helpers, which means, aha, Jan Ivar. Anyone else raise their hand? I hear a maybe from. So UN is a maybe, and
I can try to
Jan
help.
Ivar is a-
I can try to help along with Jan Ivar too.
Okay, so Randall and Jan Ivar.
All right, perfect.
Please write that down.
Okay, then we can go to the next slide. So another thing is I would like to add a few more control knobs to data channels. So we could expose more ways to control data channel specific behavior that is driven by STTP. For example, the retransmission timeout values. These could be useful if you want to do fast retransmissions instead of the default that STTP provides. So if you couple that with max retransmits, then this can be quite powerful. Another thing is we could allow to turn off the heartbeat, the STTP heartbeat, to reduce the noise on the wire, or set the interval if you want to increase the noise. Yes, and another thing that has been brought up by Michael Tuxen was we could technically set the maximum amount of retransmissions until the STTP association aborts. This might not be that useful, but who knows? So, yeah. And there's something else I wanted to bring up, which is ideally all of these are not controlled by the RTC data channel parameters dictionary, because just recently I found out that the use of a dictionary is problematic because it fails silently. So just to give you an example, just very recently, if you try to create a data channel and you set max retransmit to 0, in Firefox, this has been silently ignored. And what you got was a data channel that was completely reliable, which is the complete opposite of it you wanted to have. And even worse, if you wanted to fix that, you could set max packet lifetime instead. But that, in turn, has been ignored by Chrome because they still use the old naming for that. So I have bad news for you. If you ever wanted to use an unreliable data channel, you might actually have ended up with a reliable channel instead. So something that we could do is instead of use a dictionary, we could use something like the builder pattern instead. So instead of saying max retransmit 0 and some label, I explicitly call some methods to set this and then create a data channel at the very end. And because they are methods, if they don't exist, this will fail explicitly.
Or they could exist and do not what you want as the other stuff did.
Yeah, that might be an issue too, true. So this is something we could perhaps use in other areas as well if people like it. So that's just a suggestion.
So this is feature detection, right? I mean,
basically, yes, yeah.
And it also sounds like it's a bug. It's a bug in Firefox.
Yeah, you just fix it, but and I think Taylor just yesterday fixed the max packet lifetime thing as well.
So I mean, the dictionary part. I mean, all that means is that you would have to write prose in the spec to say, you know, if max retransmits is undefined, then throw an error, right?
Yeah.
So.
And we've already done a bunch of that since the one time we went to our RC. We've been adding those kind of things. So.
Right.
Right, which is why I added an issue on the existing spec, and then Harold told me that this is a feature of dictionaries, which I found surprising.
Yes, well, there's well, that's not necessarily bad. I mean, you want backwards compatibility, and when browsers add new features, you don't necessarily want all your existing methods to fail, because, like, let's say you add another option to fetch. Old browsers are going to ignore that, and you usually want that. I mean, is it bad that you get a reliable data channel instead of an unreliable versus no channel at all? I would call that backwards compatibility, or I would call that not breaking the web.
When it's not done as a bug, yes. Yeah. When it's not done as a bug, yes.
So generally, I don't think, DOM folks I've talked to generally don't have the concept of feature detection affect their APIs. Right? I mean, you want the most ideal API that's most ergonomic and idiomatic for JavaScript, and then if you want feature detection, you ask, well, how do we feature detect this? And you add a mechanism for that. And we did that for get user media, for instance, for constraints.
Okay, so what we want to have is a way to do feature detection, and then we can use the existing approach, which uses a dictionary. But we have to have some way to know if it's supported.
Do you?
I think so, yeah, at least for something like sending completely unreliable versus completely reliable.
There's a max retransmits readable attribute, right?
Yeah, but well,
yeah. So you can write feature detection by creating a dummy data channel, and then reading back the attribute right away, and then return true or false.
That doesn't sound like an ideal API to me.
No, but this is feature detection APIs are not pretty. People do all kinds of crazy things. For fetch, for instance, the way to check whether fetch is cancelable is to pass in a cancel controller as an object that just detects whether the object getter was accessed, and it's quite ugly. And this is considered, in the realm of feature detection, this is not uncommon.
Yeah, I mean, look at the code in adapter.js. It's not pretty either.
Right.
So.
Well, yeah, no argument there. Well, I would still prefer having a way to expose this explicitly, but if you disagree, then it's not such a big issue.
So,
but yeah.
So what I would suggest is, at this point, we're getting too far down in the weeds. We should be discussing not the details of exactly what we're going to write in the spec. We should be discussing, are these control knobs you want to have?
You're right. This was more of a side question, really. Yeah.
Right.
Okay.
So let's talk to that question.
Yep. Go ahead.
Next slide, please. So, there's another area we can improve, which is just making HTTP more suitable for requirements. And we already have message interleaving on channels, which is now specified as part of RFC 8260. But it still requires some work in user HTTP because pretty much all browser vendors use it. The question here would be, is it mandatory, or should we make it mandatory if it isn't?
It's mandatory.
Good.
IETF WEBRTC RTC Web Transports specifically states that end data is mandatory.
Absolutely. Now we just have to implement it.
Perfect. That would make the point that priority doesn't, the priority thing is via to end data, and that, yeah. All right. So
doesn't make it happen, but it makes it required.
Yes.
It means that not doing it is a bug.
Yeah.
Simple matter of implementation.
Okay, so yeah, to signal the back pressure or do some proper flow control on a per channel basis on the receiver side, there is no ongoing work so far in the SZP lab, but I have added my concerns to them. They are concerned that this might deadlock easily if they add an extension for it. But if we say we really want to have this, then they would probably reevaluate this. So yeah, there's another extension to SCTP that is currently being evaluated, which is to drop one initial RTT in the handshake. A paper is already done on that, but I have been asked to have you explicitly raise interest in this, so this can be specified in at the IETF. So
is this at association, or is this at, this would be at association time, right? So call startup.
Does this have anything to do
Yes.
with the API? Like, would the API need to change at all?
It doesn't have to do anything with the API, but it would improve.
So do we?
This would solely make the creation of a data channel and the first message going across it successfully faster.
Yeah. So I mean, is there anything to talk about here?
Yeah, there's nothing to talk about here other than they're not actually implementing it until someone says they want it. Doesn't have to be the working group per se, but
the working group could send a liaison statement saying, "Oh, we need this."
Right.
But that's the extent to which we could do something.
this would make our this would help people using it in WebRTC, and I'm absolutely good with that.
So, yeah. Okay,
and I'd
and
happily say we're interested.
Perfect. Then I'll get that message to Michael. So,
why would anyone not be interested in having fewer RTTs? Like,
I don't know.
Is there someone standing up and saying, "Please give me more RTTs"?
I really don't know why.
It's already too fast.
They
Need it
us.
to be slower.
I haven't read the paper, but I think it's a trade-off about the security. We're basically assuming that because you're already covered by TTLS and ICE, you can relax one of the round trips, which is trying to protect you from echo attacks or something.
Yeah, and that's fine in our use case. RTTs matter. That's why we pushed for 0 RTT open on data channels.
Right. And then, of course, once we have TTLS 1.3, whenever that happens, we might actually have 0 RTT set up for SCTP. Who knows? Okay. Yeah, then last but not least, we could add a more audio-video friendly congestion control. This has been, yeah, Randall has said it several times now. BBR can be added, at least to user SCTP. I have seen some simulations. You can expect a paper on that at some point. Yeah, this is just a comment. This is something that can be done in SCTP.
I would love that.
Great. So, which brings me to my last slide, I think. Oh no, it's second to last one. Okay, so explicitly for WebRTC NV, and these are my thoughts on that. I don't think we need an additional low-level SCTP API or anything like that. I think data channels pretty much leverage, with the streams extension, they leverage pretty much what we can do with SCTP. So I would propose to just copy the ORTC model, do a few API tweaks here and there if they're needed, and yeah, go with that. And possibly the last one that might be a little bit controversial is the question if we want to keep this abstraction of the RTC data transport. So the question here would be, we kind of need this abstraction if we want to add a quick transport, if we want to add a data channel on tricks transport later at some point.
I actually think we can get rid of the abstraction. Just have a CTP transport and the idea of it, yeah.
Yeah, it can be a
I think we
union
should
or
just toss
whatever.
it. Just add SCTP transport and not this abstract data transport.
All right. Okay, so next slide, please. So these are just the questions that are from the last few slides now. So any thoughts on more control knobs, opinions on the extensions we could go for? How does the NV plan sound to you? And we already talked about the builder pattern now.
So on the control knobs thing, there were, I think, 3 control knobs you were discussing. I'm certainly open to considering more control knobs. I would want to see what is the use case for those those specific control knobs before we actually spec them.
Yeah.
And what would be the plus and minus for each one. I think having more control knobs in scope is absolutely valid. And we can then discuss as to exactly what and how and what the use cases for each individual one is. And I think the rest of my opinions on the rest of it, I think, were already obvious.
My reading is more control knobs, maybe, and STP extensions. We are cheering them on, but it's not our work. And NV plan, yes. And off-topic build a pattern, no.
I have an additional tiny API point I'd like to add, which is particularly for unordered messages on a stream. It would be really nice to get the message number. The protocol already knows what it is. It just doesn't surface it in the API. And it would be really nice to know what it is. I think it's like utterly trivial to add.
Yes, and having an unreliable channel where you get messages but you don't know which they are seems a bit strange.
I'm not even unreliable, but the unordered case, like you can get 2 messages and you don't actually know which is what order they came in unless you put it into the data, which is seems unnecessary because the channel already knows.
Yeah, I mean, we absolutely could surface this. I think this was discussed when we created the original API, and we decided that the application could just throw it in their own messages. But we could reopen that discussion.
Yeah, I think before people start adding another header, which also adds some, it is pretty slow in JavaScript. It would probably make more sense to just expose the sequence number, which is pretty easy.
You're usually building the message in JavaScript anyway, so it typically doesn't add much to just put your message number in there. However, I'm fine with reopening that discussion. I don't see it, like you said, the protocol has it. So if we just find a reasonable way to do it in a reasonably backward compatible way, then we could absolutely. I certainly think it's in scope to discuss it.
Just a question for clarification. The support for adding more control knobs and possibly this message number, was that for 1.0 or was it for an extension spec?
That is a good question. Probably also an extension specs. Yeah, I don't really know. What are your opinions on that?
I would think. Go ahead. Go ahead. Okay, maybe there was.
Until I catch up.
Basically, if
extension specs are good.
Yeah, so you don't want to add yet more features that we'd have to have 2 implementations of that haven't started yet.
Especially since we still want to discuss what the use cases for it are and so forth.
Now with experience, we know that processing small extension specs is relatively small work.
Yep.
Good.
Okay.
Yay.
So are we?
Who will start drafting that extension spec?
I think we
got
figured it out earlier.
Okay, it's the same. Okay.
Same victims.
Yep.
Yep.
All right, so it's lunchtime.
No, you mean it's breakfast time.
Right.
Yeah. Same here, though. I'm in the same time zone.
It's bedtime. Good
We
night.
will return in half an hour.
I will not be back in half an hour.
Okay.
But I will try to be back at some point.
We'll see.
Yeah. I was just making a list. SCTP.